Okay, looks like we're live. Yeah, cool. Okay, hey. So today we are going to, after some weekend of Plan 9 hacking and weird running into Go issues on Plan 9, which may or may not result in a bug report, or at least, yeah, or if not actually a patch, I don't know, we'll see. But yeah, we're going to continue on with MPEG transport stream. And I thought, what better way to start than actually to just demo what MPEG transport stream is really meant for. I don't know whether I've done this before, but I'm going to, I'm going to show it here. So if I go to here, okay. So it's going to try and show what's actually going on. Okay, so assuming this HDMI cable doesn't come unplugged, which it could. So we've got our, is this gonna be okay? Yeah, okay, so try and do it. But basically we've got our computer here. This is a ThinkPad running OpenBSD. And this thing is doing MPEG transport stream over UDP directly to this Mac here. Now what's handy about that is that you don't really need any software, you don't need any really anything. How it works is that you don't need to establish connections or anything like that. There's no negotiation. It just listens, and then if it receives something, it just starts playing it, and if it stops, it just stops. It doesn't. There's no kind of. It's very kind of simple like that. It's much more like a radio, that sort of thing, than an actual, like the things that maybe we're used to. So if I go back to now, I've written this little command here. So we're actually running this down here as well. If I go here, yeah, there we go. Sorry, there we go, yeah. So that's the output of this command that we're running here. So we're grabbing the input from X, and we are just specifically choosing the primary display. So that's because there's only one display on my laptop. We're just doing 25 frames per second just because, that's totally enough for what is going to be the same most of the time. Okay, now for our output, we're using MPEG transport stream, of course. We are using the MPEG-2 codec. And you think, why the hell would we be using an old MPEG-2 codec? The sort of industry standard now, at least for, how players, most people are watching this stream now, is using, pretty much like H.264 or VP9 or, maybe HEVC, like X265, or even VP8 or something. We're using MPEG-2 because it's very old and easy for a computer to do. And for this laptop, which is not actually super old, it's only, it actually isn't that old. It's not 10 years old, but it's maybe 7 years old or something like that, I think. Somebody who knows ThinkPads would know it's a T480. But running on OpenBSD without, hardware, hardware encoding. Trying to do live H.264 encoding is super slow. Well, it's not slow, rather it's just a lot of work for the computer. So the fans start spinning up and things start lagging a bit. So we're just using MPEG-2. Now that means that we really got to, I've set the bitrate still pretty low here at 3000 kilobit. But if you were to do H.264 at this bitrate, it would, be very nice and clear. But anyway, it's enough. And then we're doing IPv4 because for some reason that's all that OBS can do. I don't know, not sure about that, but anyway. And we're just choosing an arbitrary port. And in OBS, we've just got the same thing set up to listen. MPEG-TS, MPEG transport stream on that port. So yeah, what I'm going to do is I'm actually going to put this into a little command because I think it's useful. Certainly I'm going to be using it a lot. So rather than having like a bunch of hard-coded stuff, we can just have like, I kind of imagine a command called xstream. It's like stream output from X to a given host. So what I'm going to do is equals $1. Or maybe we'll do address. Right, so it's a host port address. And then let's do address. There, so, I mean, yeah, is that going to be, maybe for now, let's just leave it at that. And then let's call it extreme. Yep. And then, yeah, I mean, that's fine, right? Like, so if what's that, 127? I can't, anyway, it's fine, whatever. And usage equals okay. Looks good. Okay. Oops. I actually have a little sort of place where I put scripts like that. I'll actually put that in there. And then I'll add a little man page for that as well. I don't think I'll do that now, will I? Maybe. Yeah, no, I'll do that afterwards. People are more interested in low-level stuff here, so won't be doing documentation. It's pretty boring, I think. All right, sweet. So that's that done. Next up is, oh yeah, of course, we got a lovely patch from Black Falcon. So we'll quickly do that before we get started on the MPEG transport stream stuff. Oh, untangled. Cool. Yeah, nice. Okay, great. Let me just make sure that I'm up to date here first. Oh, okay. Ah, yeah, okay. Let me just... Okay, cool. All right. Okay, let's apply the patch. Thanks very much again to Black Falcon. Oh, I have unstaged changes? What? No, I don't. Oh, those. How? What? Go. Okay, let's just move that to. I don't know. Okay. Patch does not apply. Oh. Hey, Ruby NT. Okay. How many other commits are there? Like, there's no. Oh no, we already have. Okay, my bad. I forgot I did it already. Okay, let's. Okay, cool. Yeah. I watched your video about how you got famous. I found it from a random YouTube video, and because I used to use Acme, I thought it was cool. Oh yeah, look, it's yeah, right. Like, I mean, yeah, it was kind of. It's not really famous, right? Like, I guess it was just a funny thing about how, like, yeah, just a bit of a story about what happened. Yeah, I don't think there's anything anything virtuous necessarily about being famous or not or anything. Yeah, but nah, Acme is great. Yeah. It's a super interesting way to think about, like, it's super interesting like way of interacting with the computer. I think is, yeah, definitely a whole bunch of interesting ideas. Hey, Red Zone 128. Okay. Let's just, I'm done with that now. I want to just like, M38 puzzle. Oh fuck there. Sorry. Bloody hell. I need this coffee really badly. Okay, awesome. Let's Okay, cool. Let's have a look at this example in the, I always like to do this, just have a look at it in the actual like documentation page, just to see what it kind of feels like. I don't get the no LSP color highlight thing. It's just, I mean, it's the same as, it's the same, for me, like, it's the same as books. Like, I think if I was reading a book, you know, like, yeah, I don't know, just to me it feels a bit unnatural to have the text sort of annotated like that. But turned off both of them. Oh, I don't get the no LSP color highlight thing. You don't, wait, what? Oh, you turned off the language server and the syntax highlighting? How long have I been programming? I think really officially since like 2019 or something like that. Maybe earlier, maybe 2018. But I was doing little bits of like sort of scripting and stuff like that before that. A little bit of programming, not much. Cool. And the thing is, this is a little bit like, it's a bit of quite a lot to look at there. Playlist. Decode. Maybe something like just printing the bandwidth is, or I don't know, something like that. Ah, I see what you mean. Yeah, exactly. Yeah. It's like, yeah. For me, it feels like that too. But for others, it's like somebody wrote the other day to me, oh yeah, but what if you've never used what if you've never written in that language before, and you want to just get really fast feedback on whether you're writing the syntax correctly? I thought, oh yeah, okay, I never thought about it like that before. Yeah, I know, yeah. Yeah, no, I know. I agree. It was just like, oh yeah, okay, I didn't think about it like that either. looks good. Cool. Okay. That's very good. Okay. Thanks again to Black Falcon. What a legend. I turned my syntax highlighting off because the language I was using at the time had very poor editor support. I highlighted things incorrectly, so I just got used to it. Yeah, I think I think that like that actually is it speaks to a good point that I think is hard to talk about. But remember that like the support for the syntax highlighting is done, you know, like per tool. So once you've got syntax highlighting on one thing, you need to implement that for all these other things as well. If there was like a very, you know, portable and easy standard for communicating the colors, for example, then I feel like that we would see that. But, you know, we're not really there, you know, because for better or for worse, what we've got is like the information that we store things in are just characters. Like they're UTF-8 runes for you know, let's say this. So that's the information that's there, and everything else is kind of gravy, right? So yeah, I feel like, yeah. Normalize highlighting in that way. But I don't know, Tree Sitter. Yeah. But I mean, even like, for example, you know, like if I like grep through a file, or if I have some other totally new program that I've never, ever, you know, that doesn't really know anything. I mean, the fact that it doesn't know anything itself is kind of, yeah, I guess, yeah, I don't know. I guess it's sort of about that. I suppose sometimes if it's difficult to read without syntax highlighting, then okay, like, is everything okay? That's kind of the way I think about it. And if that is the case, then maybe there's a, like, I don't know, like maybe there's some different way to encode text or something like that. Like maybe there needs to be a way to kind of embed that information in there somehow or another. I don't know. Maybe new glyphs or something. I don't know, like new runes, or I don't know. Just, I don't know. Obviously, there's huge value in annotating text, right? But I don't know. Shakti code, it's unreadable with highlighting. No, like the Shakti? No, I don't know that. What is that, Shakti? Oh, so all of these are thanks to what? I don't know what I'm looking at here about. Huh? Oh, like, so like count. Oh, an array length. Yeah, okay. Advertises database only, but it can't compile. Okay. Oh, wow, interesting. Yeah, okay. It's very find it very low contrast text. That's cool. I mean, it's interesting. I don't know. Look, I'm, you know. Yeah. Yeah. That's interesting. Yeah. Interesting. Look, let's let's get back to it because that's what we're doing. So no, it's cool. No, man, I could nerd out forever. Yeah. All right. Hey, we're going to get some transport stream files from our very own stream. So there we go. Okay, so that's our self-hosted stream running right now. If anybody wants to watch through there, you can get that via, whoops. That's, actually, I'm okay with hiding that now. Oh yeah, no, of course. There's a little link in the, if I point to it, down there. That's good. Okay, let's keep that there. Cool. All right, so let's open up that MPEG transport stream. Wikipedia. It's been quite helpful so far. Like this. Yep. Okay, so the issue that we were up to last time was we were losing some information from the, like for some reason, we couldn't quite decode the payload, which is pretty weird. So quite get that. But if we run, okay, there's this. Cool. Okay, self-hosted stream's running okay. Let's grab some segments from it. Cool. Okay, let's do this one. Write this damn code that we keep writing and not saving. Let's put a little bit back if we can. There we go. just write a little test to like decode the thing. I know that this works, but I'm not happy with the way that, yeah, anyway, we'll see. So we're going to try and read it in, decode it, and dump it right back out again, and then see if we can play the file and see what's wrong with it, because there is something wrong with it. If not equal nil, then we got a big problem. Let's just bail out. Oh, actually no, let's just do. And then continue. Okay, and then so we've decoded the packet. Let's just encode it right back again. Do this like okay, and then if encode the packet again to our created file, our packet. And then here we really need to, well, no, actually, let's get out of this totally. Because we can't, I mean, yeah, we don't know what's going on then. I think that's it. Okay, so now we should have a file. Alt-TS, yeah, great. Okay, so let's see what's going on with that file. So we're gonna error when loading the file. Okay, interesting. Let's FF probe it. Oh, sorry, I just realized I've got messages on YouTube chat. Sorry, I didn't see that. Hey there, everybody. How to use I want to learn how to use a light mode IDE someday. Hope you're doing well. Today I have an interview at a company the first time. Oh, good luck. Good luck. I hope it's enjoyable. Good code. Do I find any value in grinding lead code? I've never I don't actually know what lead code is. I actually don't know what that is. I know people say lead code, but I don't. Isn't lead code just like really hard code? Yeah, but I don't know, sorry, I've never done that. Okay, so FF probe. Oh, let's close, of course, we're going to close the files. Is it a hard essay based questions? Ah, okay. Yeah, I've never. Okay. I've never. Yeah, so I didn't do a computer science degree. So sometimes I definitely find that that's a problem, but sometimes it's not. So I think if, yeah, yeah, okay. I think, yeah, sometimes I think, oh yeah, I'd like to go back and like go back to uni and do it. I just had to do it for a junior role. Yeah, right. Yeah, I don't know. I don't know. It's um nah. I no. 'Can I briefly tell my story? I can. You know, maybe it'll be interesting. So actually, this is a good question to everybody. I mean, if people find that interesting, but maybe I'm more interested if people find it useful. So if maybe it would be you know, if it would be helpful. If it's helpful to hear, then what I could do is maybe I could do like just a like do a YouTube video about it. You know, just maybe like another 20-minute thing, like I did of that kind of ridiculous live streaming story. Would that be helpful? Yeah, okay. Yeah, because... Yeah, okay. Five years. Oh, well, you know, like I was... Oh, I don't know. We're definitely doing something wrong here. So we got our show. Why is it? Okay. Hey, how's it going? Okay, yeah, let me update a service on that. So we got something wrong with our let me open up Wireshark. I think I've got it installed here. I don't know. I guess it'll want a version, but I've just let it do the default version. So what we'll do is we'll have a look at Wireshark on, yeah, see what that has to say about it. By the way, for people who are interested in, yeah, I should probably link that. I found a great video talk by Rob Pike last night. Okay, I see. So Jason says, quite different compared to the regular public who uses, would love to hear the whole thing with how you ended up working on these types of cool problems. Yeah, I see. Yeah, I think definitely I feel like that the web development world has, I think it's a little bit noisy. Yeah, I think there's, No, it isn't that talk. It was one he did at a university in Sydney in Australia here. I think like last year or something. But it was an interesting kind of career, like a career talk. Yeah, it was really interesting. It was about, and the things that I feel like here are so relevant because, like, this is about, like, we haven't written code in like quite a few days now. We've just been debugging. So, and that's mentioned in the talk about how, you know, like, if you don't like debugging, then just find another job. Yeah. Which I think we can all, you know, like, I think we all understand that. But there's definitely a way to find enjoyment out of debugging. And I think that one of the ways that I'm trying to get better at is, you know, kind of how to write tests and how to write small tools to help debug. Because I know in the past I've spent a long time like banging my head against the wall just trying to do the same thing every time, rather than taking a step back and just kind of looking at it and going, and then maybe writing a tool that can sort of make the problem visible. That kind of thing. That might mean, like, you know, learning to use a debugger properly, for example. You do the same? Yeah. That, it always gets me, and I can get stuck for a long time. So, yeah. I've been stuck for a long time on things. And you, like, and when you're stuck like that, you kind of think, no, if I just keep, like, if I, you know, like if I type faster, if I like spend longer, more time, then the problem will kind of be fixed. But it's not really like that. Yeah, sometimes, of course, like you need time and concentration. But yeah, maybe not that long. Okay, let's open up Wireshark on our re-encoded packets and see what Wireshark has to say about our bad code. Looks like looks like my UDP stream has died. Hold up. I think the regular stream is okay. Conversion failed. Oopsies. Oh yeah, we just had a bit. Oh yeah, like. Oh anyway. Is that? It should be able to be. I'll keep this down in the corner now. One line of output. There we go. Let's open up another, let's compare the Wireshark output on both of the, Yeah. Sometimes questions don't have to be answers. Yeah, are to be answered, yeah. Okay, so on the left we've got our good. Let me do it like, is that okay? Yeah, that should be okay. Yep. So on the left we've got our good file, and on the right we've got our re-encoded one. So we're doing something wrong. So here we go. Let's go to packet 6 there. That looks good. Oh, there we go. Payload unit start indicator. There we go. That's it. Maybe we're not setting that flag correctly. And our adaptation field looks okay. So I feel like let's check how we're setting that that field or that flag in the transport header. So in here, let's say we it looks okay from here. So when we encode the packet, maybe we're not decoding it correctly in the first place. Okay, let's just check that first. Oh, look. Oh, no, adaptation field, sorry, no. OX40. So just to be clear, so we're looking at the, this is the transport stream header. And what we're looking at, I mean, what I noticed was that this bit here is different from our source packet. So before we decoded it and encoded it again, we had this bit set to 1. And then when we go back and look at Wireshark, packet number 6, I can see here that the payload unit start indicator is not set. So that flag isn't set, and then that probably explains why we are not, like, we don't see any payload, because maybe we, we're never saying that there's ever a payload or something. I mean, yeah, we say there's a payload, but not that the player isn't able to start it. Like, the player isn't able to seek to the beginning of the payload. Something like that. I'm not sure exactly how the players handle it, but six, 7, 8, 9, 10, 11, 12. See, even these, so packets 7 and 8, for example, let's look at 7. Don't need that. So in packet 7, we've got adaptation field control, payload only, okay? and then it's reassembled in 9. So let's look at 9. Yeah, we haven't got any, see that? So something there. We've got the adaptation field length is correct. And then, okay, so we just got a bunch of stuffing, whatever. So the first packet where the, so this, I would imagine that the, see, so we've got packet 9 here and it's reassembled. So it starts at packet 6. So I guess payload 6 must have the payload unit start indicator set, right? Which is what we're looking at. And here we don't. Fuck, so what's with that? Are we, is it the way where like, this is all synchronous, right? So, I mean, at least, you know, obviously not underlying all the hardware and stuff like that, but what we could do is actually write out the packet at packet 6 or something like that. Yeah. It's weird though. Hide. There's just, wow, it really fucks up there. What's the first packet? Payload only. So the first packet is payload only, yeah, and then okay, one thing we could do is we could what says start shoving asserts down its throat? Yeah, pretty much. Yeah, just like, yeah. Yeah. We could even do something like have our own little buffer here and then just checksum each byte that goes through. Checksum each 188 byte packet that comes through. And then compare the checksum at the end and go, well, hey, like these things, because this needs to be byte for byte equal. If it's not, then that something's really wrong. And I byte for byte, and I mean bit for bit. Yeah. Just funny, yeah. I feel like that packet 6. Let me hold on. Let's do, yeah, and then let's go down and right do this, blah blah blah. Okay, if I is 6, break. Yeah, let's just do that. Okay, and then let's now reload. Okay, there we go. All right, so yeah, I mean that kind of says it, doesn't it? So packet 6 should have the payload unit start indicator set, but it doesn't. So if we go and look, So when we're decoding, let's just check that. Oh no, let's go if I equals 6, okay? If, yeah, and now indeed, let's start shoving the asserts down its throat, which is one of the best suggestions I've ever heard from what is good. Okay, that's one error, and then let's just do that just to start, and then we'll payload. Okay. What? Okay, so when we decode the packet, we're setting the flag correctly. So now we need to check in when we're encoding. Oh, it's this. It's this. There we go. That's it. It's there. This thing zeroes out that probably zeroes out the flags. Right, so yeah, that's it. Okay, so we found it. All good. All right, so let's we need to manually pack these 13 bits into the 2 bytes that we've got. So so let's do, we need to pack the 13-bit PID. So big endian, so that means that, damn it, every single time I do this bit packing stuff, I'm like, how do you do that again? I've been doing this for a little while now. I just can't fucking remember. I just find it really hard. Like, I don't know, yeah. Okay, so we're gonna get the, well, our first byte, okay, let's just do it really simple. It's gonna be I'm going to do one of these diagrams again. This is the diagrams help, okay? So we've got, this is our header. Okay? So what we've got is our error is 8 bits. So E, 1, 2, 3, 4, 5, 6, 7, 8. Okay? That's our first byte. So let's do 1. Okay? No, let's do 0. Yeah? Okay. Our next byte starts with the error flag, so that's, sorry, this is sync, my bad. This is sync, so let's do this, actually, so it's G, so let's do 1, 2, 3, 4, 1, 2, 3, 4, just because that's the byte that they use as like a special marker byte, the value. They use the letter G. Okay, next up, we're gonna do the first bit of byte 1 is the error flag. The next one is the payload start, so let's call that start. The next bit is priority. And then the next one, we've got the 13-bit PID. So let's call that I for ID. So we've got 1, 2, 3, 4, 5, and then we go into the next byte. So let's do it like, if I may, I'll just do it like this. I'll split it up like that. Then we go into the next byte, and that's, so now we're gonna 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here's our packet ID like that. There's a better symbol I can use here. Hold up. Do a slash. I mean, why not? Okay. Or something, I don't know. Do a dash. Yeah, anyway. So our 13, so 1, 2, 3, 4, 5, 13, yeah. So we can just start with this. So we know that this byte at index 2 is just going to be the value of p.pid. Wait, what type have we got our PID set as? Right, okay. Yeah, okay, all right, well, yeah. So we've stored it in a uint16, so that means to get those bits, we need to shift 8 along, right? Oh, sorry, no, that's buff 2. So whoa. That's just that, and then this one is going to be byte of p.pid shifted. Yeah, shifted 8 along. Yeah, like that. So what we need to do is then toggle the bits in that byte. So let's do that. So this is going to be buff 1 toggle, yeah, like that. Yeah. We could do some checking here and say, hey, like if the PID is greater than the 13-bit integer, then like, you know, yeah, that's very bad. I feel like we should do that here actually. But for now, let's just do this. So maybe. Check that is, you know, fits in 13 bits. Okay, and then like that. So I think that should be it. Now let's okay, let's open up Wireshark and see. No, still haven't got it set. Am I shifting the right way? Oh no, wait, we're parsing now, so. Huh. Hold up. Oh, no, we're always parsing. Yeah, okay, so we're not getting that. So let's go, what we could do is actually try to decode our encoded packet. Oh no, we haven't got access to the... Yeah, no, okay. Let's, you know... We could write a little test to see if we're packing this correctly here. Let's do that. Let's test that. Okay, let's do this. So let's say the sync byte is, oh, whatever. Okay, let's go. Error is true. Payload start is also true. Let's set all of these as true. So we'll toggle all the flags, and then we'll try and pack the PID, and then we'll see if we've like lost the flags. And we'll set the as something. We have some constants. Okay, let's do this one. The packet ID. So PAT. Okay, so we'll do PAT. Okay, so let's encode that. Oh, hey, that's super kind. Thanks so much. Yeah, so Cosmo says, hey, I cannot stay to watch the stream, but I just wanted to say I've been loving the streams, have been learning a lot. Keep up the awesome work, man. Thanks, hey, thanks so much. That's super kind, yeah. Yeah, I just hope that, you know, yeah, like as I always say, like I've learned so much from reading and, you know, watching this sort of thing. So I'm hoping that, you know, this kind of, yeah, spreads more of that sort of thing. So that's cool. This is being recorded, so you can watch later or whatever. Yeah, that's cool. Thanks, mate. Super kind. Oh. And then we'll read it back again. So let's go decoded is decode from buff. Yeah, and then we error out if we've really got something wrong there. And then, okay, so now we check. So if payload start is not, oh no, we'll do if decoded.payload not equal p.payload start, yeah, then we got something wrong. So decoded is that, and the source is that. Okay, there. Priority. Oh, right, the pointer. Okay, fine. Oh, wow. Oh, yeah, because we're missing stuff. Yeah, okay. Yeah, of course. This is actually invalid. Yeah, this should actually error out before. So let's kind of make it more of a we need some Hey, FitRider. It's going well. We're doing some good little debugging here. We found a little problem and we're about to get it, I think. Okay, this is the one that we want. So we're going to set the raw bytes, stuffing. I just want like a... Oh, I know. I've got a good idea. Let's actually just copy the... No, not that one, but from the packet here, this thing. Yeah. See, the adaptation field in this is just, it's only got one flag set, that's it. And then the rest is payload. So let's do that. So adaptation is, and then the only thing that's set here is the random access indicator. Okay, so random access is true. Okay, and then the payload is going to be some number of bytes. It's going to be everything from 40 onwards. But actually, we can just set this to 0. So let's see. So if we've got 1, 2, 3, 4, 5, 6 bytes, that means that it's 182 bytes of, payload. And it doesn't matter what that is. We can just set that to 0 because we don't know or care what that is. So let's do that. So we're just going to do just 0 bytes. Make. Oh, I can just do it here. Of, let's do 188 minus 6. Just do for now. It's kind of dirty, but just for now, let's just see what we get. Mismatch parallel start indicator. There we go. All right, cool. So we've reproduced that bug. Awesome. Hey, Ray, how's it going? Are we cooking? By the way, is this a hobby project? Yeah, I guess it is. Yeah. Yeah, it's a kind of a, I mean, I've worked on this stuff for work before, like I've done projects with this kind of thing before, but yeah, I guess I feel like it's a shame that I feel like that, yeah, I feel like it's, I wanted that to be open source and more general. And so I guess that's kind of what's happening now. Yeah. Okay, awesome. So now we can iterate on this pretty quickly. So let's do that. So we're not doing this right. So okay, let's test packing this thing. So we're gonna have a PID of, let's start with the top here. Let's go PID. So PID is, let's do this. I don't know what that is, but who cares? Let's just do that one. Easy is the cat. So let's say we had in our diagram here, we're going to have these 3 bits set. So let's start with that. So we've got our let's call it our sort of, yeah, something. Oops. There we go. Just call that byte equals. Okay, so in our representation, we're going to have 1, 2, 3, and then just all zeros after that. So 1, and then 1, 2, 3, 4. Okay, so that's our bit layout that we want first. And then when we pack it, so what we want is actually, since this is just a value of 1, what we want is OB 1, 2, 3, 0, and then 0, 0, 0, 1, I think, right? Because a value of 1 is just 1 there. Oh, unless I fucked up the big endian thing, which I can't remember. But anyway, let's just do it like this and see what we get. There's 1 in big endian. That will just be 1, won't it? Oh, no, it'll be the significant bit. The value then would just be, hold on. So we'd have, yeah, no, in big endian, then with the first byte, no, so this isn't correct. It would be, oh no, sorry, yeah, yeah. Hold on, give me a sec. I need thinking time. Okay. One, two, three, four. It's 5, 6, 7, 8. Yeah. Yeah, sorry, I got this wrong. So the value that we want is yeah, I need to think about this for a sec. Okay, if I think, and then I should be able to say it in words in a little second. We'll just think. Because all that's going to be 0. That is certainly 0. And 1 is going to be 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so there's 5 zeros here. Okay, let's do our array. I'm going to do an array of 2 bytes. 4, 5, and then okay. Okay, these are our packed. This is what we want when it's packed. So this is the same as having a packet where, oh, well, let's say this packet here, minus adaptation and payload. So we're going to have our, so first up, we're going to have all 3 of these set. So error is true, payload start is true, priority is true. And then we've got our packet ID. This is just 1. 13-bit integer value of 1. So encoded, that's going to be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and then just 1. So packed up, it looks like that. So if we now do our logic, let's do, again, we've got an array of 2 bytes, so let's do, all right, let's go array of 2 byte. So we're going to start with just the flags. So that'll be 1, 2, 3, 1, 2, 3, 4, 5, and then this is just 0, so 0. Okay, so then so to pack this PID, we want to turn that into a 13-bit integer. So we're going to extract the 13-bit integer value out of this thing. So to do that, at least how here we've got it set up as doing, is we're going to go got O or equals, yeah, byte cat shifted 8, and then 1, something like that. And then we can, and now we can just test, and so we can say, okay, well, if 1 is not equal got, then we're not happy. Okay, so we're going to do, let's just, yeah, we'll go here. Okay, there. Okay, PID declared and not used. Oh yeah, okay, well let's do that, yeah, okay. Ah. Interesting, right? Let's comment this thing out. Huh. What? So how come... Oh, fuck. Well, oh my God, we still got this here. Oh, oh God. Still had the old code there. This thing. Oh, fuck. Yeah, there. Okay. That's it. All right. Yeah, well, okay, cool. We got it. We got it. It's all good. Kythron says, hey, hi Kythron4. How is your day? Good, thanks. How is your day going? Yeah, okay, cool. That's good. So let's grab our... Now that we've checked that, let's actually do a... Let's grab the maximum value there, which is... There's a way to represent this that's better than what I'm doing. We can do a bit shift, I think, to represent that, but first we'll just, yeah, let's just save that, all right? Yeah, okay, there we go, all right. So, I feel like I should save this somewhere. And then, yeah. Cool. Okay, now if we run our test again, and this time actually don't bail out on the 6th thing, let's do that. Right. I think if we actually play this file, it should just play. Right. I mean, let's do it like this. Okay, 6. Payload indicator start. Okay, cool. 9. Oh yeah, looks good, looks good, looks good. Okay, here we go. I just do it in here. Yeah, there we go. There we go. Seems very short. Hold up. And oh no, it's different still. $2079. Okay, that's fine. Oh, well, that's good. Okay, well look, I'm gonna yeah, that's great. We're further along. I want to just try this again. This feels a bit short. let's do this. Let's print more on YouTube. This guy is who the Primogen thinks he is. I know that the Primogen, yeah, my friend sent me a link to that. That's funny, that one. Yeah, that guy's crazy, man. Yeah. Okay, so we've done that. Can you, can you, Kai314? Interesting. So there's still a little bit of difference, but that's okay. We could actually, 2079. How many packets would that be in? Packet 11 apparently. So apparently this 11 is different. Header's the same. Because this here is actually in the payload, which we don't touch. We're just having that as just a raw slice of bytes. Maybe it's in the next one. Adaptation field. I mean, I could really be really hardcore and like just read the value of the bits here. So character 2079 would be a little bit through packet 11 apparently. Oh, 101. 011100. Okay. Apparently we don't care about. Weird. Maybe the number of stuffing bytes? No, but it can't be the number of the stuffing bytes because that would 26 bytes. 26 bytes? Yeah, weird. 1 byte pointer. Byte pointer. Value 0, yeah, okay. That's text, whatever. Yeah, funny. The header X fossil services 1C, yeah, that's the same. 01C0000 E1. Oh, yeah, let's have a look at that diagram. Okay. Well, that's fine. What would be... What might be a good little test here is to also like, rather than writing it out to a file, we could actually just write it out to a, like a fixed size buffer. And I say a fixed size buffer, like an actual array of 188 bytes. And then, so we have two arrays and we just do a simple value comparison, because we can do, we can use the equals operator in Go on arrays, but not on slices. So that would actually be pretty good, because we know that it's 188 bytes. So maybe we want to do that. So let's okay. Let me go on a quick tea break, and yeah, we'll and I need to do the washing and stuff. So that'll take 2 seconds. So yeah, let me just do a quick this. There we go. Oh, what's going on? Oh, the cable, yeah, that's fine. Okay, cool. All right. See you in a sec. Just a few minutes. Oh no, go for down. Right, there we go. All right. cool. Back to here. Okay, so there's our test. I feel like what I want to do is not do that. Well, yeah, not write out again. That. I'll write a quick check on how to because the largest 13-bit integer is the same as this, right? X 1, 2, 3, 4. But then shifted, if we've got 16 bits, so it shifted 3, right? Is that the largest 13-bit integer? Because say another way to do it is like do, so we go 2 power 13. Yeah, that's it. Yeah. So let's actually do that. So in our PID, here we go. So let's do a max. Maybe the, oh no, actually here, we can even just do it. Let's do it like that. If it's greater than packet null, then, you know, packet ID, greater than, max. Right, so that's, and then that's packet null. There, that's pretty good. Wrong type, int. That's nice, a packet ID. Error format. There's a string method. Ah, this is, yeah, there we go, okay. We'll do that later. Cool. Okay, that's looking better. I say it's a good time to make a commit for that. Sure about, I'm not going to save that test for now just because we're like, got a random file on disk, but yeah, let's do that. We'll just pack PID. Oh, actually, well, the test isn't, yeah. Well, so while here, validate value of PID. Add validation for. Okay, and then yeah, that's good. Okay, let's save that. Cool. Okay, cool, great. Now what I want to do is actually get the, let's get a Big Buck Bunny segment and store that in, let's just store that in here somewhere. So okay. Add insertion, Big Buck Bunny 480p. Yeah, that's fine. Yeah, let's grab that thing. All that. Okay, cool. So that means that let's save that to test data. Just save it as that file, I guess. I mean, I don't know. Then we've got a good test, and we can keep this file in the repository. It's fine. Like I don't think it's that big. We'll see anyway. $885K. That's okay. all good. Okay, now we can update our test to actually read from there instead, and then, you know, we're looking better. We'll just hard code that one for now, and then, you know, it's fine. Okay, cool, done, and then this I'm not, yeah, like this I'm not really, I don't know, like, I don't know whether that's such a useful test. I mean, this is just some logic that we don't even have in the code. We need to copy and paste that, so I'm not super, I'm gonna get rid of that for now. And then this, I feel like this could be better done up here with something like a, you know, like we were talking about, was that array. So actually checking that the 188 bytes that we read in is exactly the same as what we write out again when we decode and re-encode it. So I feel like I feel like I'm gonna get rid of that too. Okay. Now we can, yeah, like let's just save that test. So codec test data. Rid of that. Okay, I think that's it. Yep. And we don't want that. Cool. Okay. MPEG-TS, okay, so the more thorough testing, like checking encoded packets are bit for bit identical from coming next, right? So I'll do that. Okay. Cool. Send that up. Don't need that anymore. Your stream is interesting to learn. Oh, thanks. Yep. All right. Mm-hmm. All right, let's let's do that test we were talking about the yeah, because we've got so we're going to decode. So we want an IO reader. So so let's do our in is a array of 188 bytes. And then what we're going to do is we're going to read from the file, and we're going to read that into in. Okay, so if I think, yeah. Oh, this is n, whoops. If n is not equal packet size, then freak out, right? I'll check if we've got AOF again. Let's put that down here for now, and then we're going to go. Oops. Yeah, this is going to be here. Okay, so else if there, and then if we've got something else, then read packet. Okay, now we can go decode from new reader from in. Now, okay, then we're going to really bail out there. So decode packet. So why we're doing this is that so that we can compare the value of in at the end. So what we're going to get is yeah, that's it. Okay, cool. So that's all right. So now we need to write our encoded packet into something. So let's do an out is 188 byte. Out 188 bytes. So we're going to do a can I do a what's that? Maybe I'll just read it into the buff.io. No, I don't care about that. Maybe copy. Yeah, look, okay, let's just do a buffer of this. Bytes dot new buffer from out, and then we'll from there then we'll write it into, so we'll encode into our buffer, like that. And then now we can finally test, hey, like, are the 188 bytes that we read in exactly the same as the 188 bytes that we eventually encoded? So if in does not equal out, then, you know, now we error. So the encoded bytes, the encoded packet and source packet bytes, something like that. And then we're gonna do, geez, I don't know how we're gonna packet. We could print out the bytes that differ or something like that. Or we could at the very least, let's print the actual packet that's mismatching. So plus v, the p, and we're going to log. So we're going to do source is that in, and then encoded out. Looks good. Okay, now if we run the test, it should fail straight away. If I could write correct syntax. Okay. Looks like every fucking packet has got something wrong with it. Okay, what we're going to need is whoa, holy shit, that's like super wrong. Oh no, maybe it's not, sorry. The source encoded is 0. Well, that just doesn't seem right, does it? Fuck. Okay, so that's the source packet and encoded. What the hell? Let's count the packets as well, just so we know. So packet encoded, so encoded and source bytes differ. It's better. Packet 1, packet 2. Okay, so I'm fucking something up with this thing here. So we're reading, yeah, something's, Okay, we're reading it okay. It looks like something to do with the decode from the array. Okay, doing another array. Oh, the buffer is, yeah, right. Okay, so it's not, it's using that as the buffer, but that's not the value of the, yeah, okay, all right, hold up. So this is gonna be, yeah, okay. So the bytes are sitting in the buffer, not in our array. So we're gonna do this, and then we're gonna copy into out from there, like that. Yeah. Yeah, okay, I think that looks better. I mean, we could move this up to the top and whatever, but yeah. Yeah, a lot of that, it's obviously like, this is obviously super inefficient, right? But yeah, don't care. It's inefficient because we're like allocating all these things. We could just reuse the same ones. But we can, what we'll eventually do is we'll make a scanner, like a packet scanner, and that's really a much better interface. Like a scanner that we see in the standard library with the in the buff.io package. We'll basically just copy that, and then, but instead of for reading text or whatever, we can just do, maybe we can actually reuse that scanner, write a scanning function. Anyway, we'll, yeah, that might, anyway, yeah. Oh, yeah, I don't know. Anyway, let's, yeah, let's get going on this. Okay, so we've got the, I just want to make sure that that's, I guess that's correct. Like what we're reporting is actually what, so apparently packet 4, the things are different. So let's rerun the whole thing, let it finish. Okay, there. Oh yeah, let's swap this around, right? So we want this at the top, because if it's EOF, then we're good. It's fine, we can just do that. Okay, and then we'll do that, and then we'll do that. Okay. So packet 4806. What's this file again? 800, so it's 800K, this file. Yeah, okay. Let's try and find out where it's different, I guess. Let's open up Wireshark again, because, yeah. Okay, we've got 4. What's different about 4? Anything unusual about it? adaptation field, okay. Let's do a, yeah, TS pipe, here we go. This is what we want. Yep, so we decode from standard input and write it to standard output. Yeah, great. Okay, let's run this command on our test data. So if we've got that open still, yep. Okay, and then we'll load it up again. So we'll go run. Okay, so we read in from test data, then whatever that thing is, and we'll write it out to just there. Okay, and then we'll open up Wireshark on this. And we should have 2 Wiresharks open, and then we can, so packet 4 apparently is different, so let's see. Oh, I just realized that my stream has died again. What the fuck? Why is it going? Overhead, no buffer space available. Interesting. Oh. Uh-huh. Weird. Sorry, give me a sec. Looks like the... Properties. Oh yeah, there we go. Okay. Probably should look into that. I should look into it by like actually using Ethernet instead of fucking 2 Wi-Fi things and whatever. But anyway, for another day, right? Okay. So we got packet 4 apparently is very different. So 7, yeah. The header is the same. Adaptation field. 1001 0. Interesting. Okay, so on the left, let me get this right. And then the original is, okay, so we've got our original, we've got our source on the left and our re-encoded on the right. Yeah. Packet ID is the same. Oh, let's open this header up. Is that the same? Yeah, 0, 1. Same, 0, 0, 1, 1, 0, 0, 0, 0. Okay, let me check that this, like, the logic is right here, because this seems a bit, maybe this is off. let's do like this, right? Like log, you know, the byte, you know, so let's just do the byte. Do that instead. So let's print our packet first and then okay. Okay, so in packet 4, apparently the 10th byte, or like rather the like 11th byte, it's got a value of 126. Out 0, 126, out 0, 126, out 0. Whoa, what? Oh no, so on each packet, yeah, okay. So packet 4. Oh, these some reserved bits maybe. Could be that. But let's go, so source 126. Fucking hell. Let's go to Wireshark, okay. So we got byte, no, wait, no, it was 10 bytes in. Hold on, how many bytes? Oh, yeah, the 10th, oh no, that's easy. Okay, so 1, 2, 3, 4, 5. I don't see 126. Oh, no, that's, yeah, okay. Sorry, yeah, that's a payload is way later. Oh no, but I think it's still relevant, yeah. Huh? Adaptation, okay, no, we're gonna need wire, whatever. Okay, so byte 10. Okay, so we got, let's have a look. So apparently in our, so 1, 2, 0. Yeah, okay, it does index from 0, great. Okay, so 0, 1, 3, 4, 5, 6, 7, 8, 9, 10. 7E. Okay, that's fine. Yeah, there we go. Okay. It looks D5067E00. Wait, what? So the PCR is actually equal, right? But the value of the, I think it's those reserved bits. So if we look at our clock reference is 33 bits, 6 bits reserved, and then 9 bits extension. And we've got that in our code. So we go to here. In our adaptation field, PCR. Yep, okay, here we go. So here's our thing here. So 33-bit integer holding the number of ticks of a 90 kilohertz clock. So we've got 33 bits, 6 reserved. So do I maybe need to store the value of the reserved bits or just have them all toggled to 1? It feels like I need to have them all toggled, but just because I ran into that before with the run into that before with the with Scuddy 35 as well. The reserved bits, like, yeah, they were all toggled. So let's go down. So let's say when we read our PCR, yeah, parse PCR. Okay, here we go. Here's our stuff. So next 6 bits are reserved. Ooh, excuse me. Oh no! No, it's when we encode it out again. Yeah, so it's when we pack the PCR. So let's have a look. Here it is. Put PCR. Yeah, okay. So this put PCR function, it takes the clock reference and puts it into this slice of bytes. So there's us packing it up. Do we need to, let's draw a little diagram again. Okay, so we've got 33 bits. I'm going to really do this. Yeah, fuck it, we'll do it. Okay, so we go 1, 2, 3, 4, 5, 6, 7, 8. There's 8, 16, 24, 32. Reserved 1, 2, 3, 4, 5, 6, 7. No, just 6. 1, 2, 3, 4, 5, 6 reserved bits. And then the rest is the extension. So that's 1, 6, 7, and then 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's the bit layout for our clock reference. Okay, so we've got at 0, 1, 2, 3, 4, 5. Okay, and it fits into 5 bytes. So that means that we want to toggle all those bits. Yeah, that's it. So one way to do that is that we know it's in B4, so we could go B4 and then we could do get the mask for that, which is like OX something. So the value, those values that we want to toggle there would be 0, 1, 2, 3, 4, 5, 6, and then 0. That's what we want to toggle. So if somebody, there, so I want that value in hex. So I'm gonna look at my hex tables because I'm still like a massive noob. All right. It's funny, I just can't. Okay, OX. Oh fuck, no, that's dumb. Rapid tables. Yeah, it's more like it. 1, 2, there we go. So it's OX7E, right? And so that means that the value in Wireshark should also be 7E. Fuck yeah, there we go. All right, cool, we got it. Good. So 7E. Here we go. Okay. Oh yeah, oh, it passes, bang. Woo. Oh, here we go. Mark Leonard just wrote on the YouTube chat, headed to sleep, but came on to say I love these streams. Oh, yeah. Thanks. Thanks, Mark. That's super kind. Yeah, sleep. I don't know what time. Here it's 1:45 in the afternoon. So wherever you are, I hope you have a good sleep. Whenever it is, wherever you are. Sweet dreams. So yeah. Okay. Awesome. All right. So so our test just passed like just that? Yeah. So we encoded and source by so encode, and then let's do encoded. Wow, great. Well, that's good. Okay, let's yeah, that's great. That actually worked really well. Oh, Sneaky Donkey. Hey, how's it going? How's your low-level Linux and like socket investigations going? Hey. I'm tired and must work some hours. Today I looked at poll and then shut down. Oh, nice. Yeah. Oh, poll. Yeah, poll actually. Yeah. I'm super interested how that. I have no idea how that poll worked. Like, I mean, poll and ePoll and KQ and yeah, that's super interesting. Oh shit! I just realized that the stream's busted again. My stream from my computer. No. There we go. Damn, I did a lot in that time. The behavior of shutdown differs from its documentation and is very different on Linux and Windows when you do shutdown, SK shut RD. I would say don't ever use shut RD. Okay. What's that RD? Poll is very inefficient for a large number of connections because for each socket you need to copy 16 bytes to the kernel. Oh, what? Yeah, right. 1,000 clients, copy of 16 kilobytes. And in response, the kernel might tell you that you can read a single socket, maybe, and then you read 1K from it. Yeah, wow. And then for each and every time, you can tell the kernel that you don't want to read from or write to a socket. Yeah, right. Interesting. Oh, with shutdown. Ah, so that's what shutdown actually does. Yeah, right. Cool. Huh. Yeah, right. Yeah, wow, that's cool. Yeah. I'd love to look more into that kernel stuff. And like, I just exactly like comparing Linux and Windows and stuff like that. And then all the other operating systems. That would be, yeah. I thought it did release send receive us, but it doesn't. Yeah, yeah, exactly. And all others. Yeah. I thought it'd release send receiver, but doesn't. Complete waste to call shutdown. Tell me can't it. Ah, okay. But it doesn't. Complete waste to call it. Tell the kernel you won't send any more data. Yeah, yeah. Weird. Maybe it's there for like compatibility or something? Is that... I don't know. Maybe like it... I don't know. Yeah, who knows? Or at least maybe it was there as an idea. And then like whether or not it actually does anything is like up to the implementation or something. Okay, yeah, maybe, but the behavior between Windows and Linux is so different. I guess it was an idea. Yeah, interesting. Cool. Yeah, that sounds good actually. Yeah. That's working some hours. Yeah, okay. Is it oh, so I guess it's like, because you're in Europe, right? So it's maybe 4 or 5 a.m. in where you are. Oh, in Ireland. Oh, Ireland. Yeah, that's right. So I was thinking that someone was in Germany then. Yeah, because, yeah, there you go. Oh, yeah, because that's actually minus... Yeah, you're back an hour again in Ireland, yeah. And then this commit also... byte for byte check on packets and reports which... Okay, that's great. I'm very happy with that. Okay. Cool. Okay, good stuff. All right, so we let's try and play that. Let's try and play the file again. So if we run our TS pipe program, which if we do that, so the TS. Actually, let's just pipe it directly into ffplay. Okay, and then let's see what goes on. Cool. This looks good. Awesome. Okay. Now you won't be able to hear the sound, but I can. And then that's it. Okay. Awesome. Whew. Great. Okay, we're finally doing a dumb... Yeah. We're finally doing the most useless thing. Just decoding the packet, doing absolutely nothing, re-encoding it again. So this would actually be a fun exercise to like benchmark it, right? Because now we could sort of... maybe what we want to do is write our scanner that anyway, we'll think of a few different things to do here, but that's yeah, that's cool. And I think, yeah, so we handle the, wow, yeah, that's holy shit. That's great. I'm actually super happy about that. There's barely any, there's not a lot of code there. And that means, for example, say if we go to our, is that, oh, fuck. If we go to the Go doc, which is somewhere there. Okay. So now for anybody who's stuffing around with MPEG-TS, with MPEG transport stream, you can sort of, you know, that gets you some of the way, right? Because you can go into the adaptation field and start messing with stuff. And the payload, well, yeah, okay. Can't work with the payload, but yeah. We could do, yeah, there's one important field that I do want to, like one important, let's say like, let me get that right. There's one important type of payload that I want to actually decode, because that's all to do with syncing and timing of video and audio and playback and stuff like that. And that's a thing that comes up in the real world quite often. For example, on the streams here, here we go, PTS. So that timestamp shifting seems to be quite common. I was speaking to somebody else who had to do that, and then I've also had to do that in a work project. So yeah, this is yeah. So we'll do that. That's the I wrote in the title of the stream, I think. Did I see adaptation field? PES. Yeah, there we go. Yeah. So let me just check the chat and stuff. Nice. Okay, cool. Oh, Travis, you subscribe. Oh, no, hey, thank you, Travis. Super kind. Thank you. I hope this is, yeah, I like I always say, I hope this is helpful for you and like everybody else. Like, I hope it's useful in some way. And if anybody's got anything else to share, like, please share that, you know, like there's, yeah, it'll be cool to get some sort of, yeah, I don't know. I don't think, yeah, absolutely. Thank you. Yeah. Yeah, but I think that there's a lot of software engineering that goes on that maybe we don't see, or there's parts of software engineering that we don't see, and there's a lot of weird sort of hype stuff going on as well. So, yeah, I hope this, you know, this inspires other people too. MX Terminator. Cool. Sneaky Dunk says, I'm passing some JPEG format. Yeah, so there's a new codec. A JPEG, well, it's JPEG in the sense that it's specifically for video. It's like a super low latency. It's a codec that's designed to be very low latency and low implementation complexity. So the idea is that it's for like embedded devices. It's really for like live studio broadcast environments. It's meant to replace SDI, which is sort of like HDMI, but not. And it's meant to make it so that it's sort of like a reliable, easy way of doing you know, sending video, audio, and a bunch of other stuff over IP. So over Internet Protocol, instead of like serial of SDI and all these other things that exist. It's sort of like a suite of standards, and JPEG-XS is one of the codecs that they want to use for the vision. And yeah, I was just interested in trying to implement that. I think that will come later because, yeah, there's a lot. I've read through the spec and stuff, and of course there's a lot going on there. But yeah, it sounds possible. So yeah. Hey, what's up, man? Long time fan of you. Do you feel the big O-Time? Oh, thank you. Very kind. Having trouble recognizing these issues first. I'm having trouble recognizing through H.265 through NDI product. I wanted to stick out, and police called immediately. Didn't have a solution. Yeah, right. Okay. Yeah, right. I got no solution for you, mate. Sorry. Sent through NDI. What? Are you joking? How do I what? I need to, sorry, I'm gonna how do you ban somebody again? There we go. Cool. Okay. There we go. Okay, cool. Okay, I don't know what that was about. Some fucking racist guy or something. Okay. Anyway, all right. Sorry about that. Let's. Okay, cool. Let's delete those messages. Great. Okay, no time for racist shit around here. Too busy hacking. All right, cool. So yeah, let's let me read through the let me just sort of overview what we've done so far. So we're reading through the header, and we're also reading through this the adaptation field, which is like this optional field that is set on, you know, quite a lot of packets. And yeah, that's that. So the next thing I want to do is actually look in the packetized elementary stream. So this is a kind of like, well, yeah, essentially it's another packet that sits within our MPEG transport stream packet payload, and that will and this contains also other timing information. So what I want to do is I'd like to go in there and yeah, basically parse it, deal with it, that sort of thing. But before I do that, I want to have some lunch, and I need to do a couple of, let's say, work-related things. So let me just, yeah, but so next up, we're going to work on this, thing. So this is a type of, basically it's just a small, tiny little payload that sits in some packets. And it carries timing information for players and stuff like that. Okay, cool. So let me go on to no. Okay, hey, so I'm just gonna set this to something. Back, I mean, is an hour too long? Let's do this. Bloody hungry though. Oh no, we've got a little. Okay, and then I'll just do this, and then we're going to put our, oops. Zoom in. Lunch break. That actually works a lot better than I thought. I didn't realize lunch and break would actually. Oh shit, let me turn that mic off. All right, there we go. They're good? Yeah, lunch break. Sweet. All right, cool. Okay, all right. See you in about an hour. Grab some food first. Yeah. Okay. right. Fucking hell, it's cold. Okay. Can just close that for a bit. So I'm just going to do a couple of emails and stuff like that, and then I will come back. They just, no, not done with JPEG-TS. No way. I will come back to it though, but later, I think. Yeah. Since I asked, go to transition screen. Always good to see you, Cody. Thanks. Yeah, it's great. Good fun. Okay, let me just do this email and then I'll come back. Okay, hey. All right. So, so. I guess, oh yeah, the screen is still running. Okay, sweet. Hey. Hey. Alrighty. So let me just think that's how to do this. What we want to do maybe is just like create, rather, I mean, I sort of know how to do it. I'm just thinking how best to kind of show doing it. But basically what we're going to do is we've got our packet here, which we seem to be sort of encoding and decoding okay. There's a payload that I want to read in and be able to, again, also decode, encode, and kind of stuff around with. So that's the next thing I want to do, just because it's sort of important for, I mean, I've, speaking with other people in broadcast and like streaming and whatever, I've also had to do this myself. So what we're going to do is we're going to get a packetized elementary stream, or PES. So so this is the stuff that actually has the encoded, like, let's call it like the real payload, like the audio and the video. So let's start like looking at this thing. Oh, hey Travis, I just replied to your email. What? Oh, well, do you want to? Assuming there it says what the length of the field is. Yeah. So, that's right. So it's here. So you start off with like a marker just to know like what you're looking at, and then you'll have a single byte that tells you what the, like what kind of thing it is, and then you'll have the length there. So it's just a 16-bit integer. And I can't believe it's actually just 16 bits, thank you God. It's not like, oh, like a 12-bit integer. No, just no more of that bullshit. So this is cool. Nice normal 16-bit. And then, I guess that's it, yeah. How do I do with variable length bytecode field? I'm assuming this is length of it. Yeah. So I guess that's here. And then also, if you're wondering, Travis, the actual transport stream itself, this has actually got a fixed packet size, so it's 188 bytes. That's like the rule. So, but in each of these, you'll always have a length. So this is a fixed size, so that's 4 bytes. But then in each of these, you'll pretty much always have you will always have a length prefixed, or a length prefix, yeah. So here when we've got adaptation field, that's number of bytes. We'll have things like, yeah, in this one, for example, the length here for this private field. And then we've got another one for the extension field, and that also has the length. What we're doing in Go to, yeah. And then how we do it in Go is we don't actually store the length. I mean, we do, but we're letting the runtime deal with that for us. Well, not really letting the runtime, like we're kind of letting the type system do the lifting for us there. So for example, like we know that this thing has got a length stored in it. And so, yeah. So for example, when we're encoding the packet again, you know, we've already got the length there, so we don't need a field here that says like, you know, payload length or whatever. You know, would be like uint16 or something, because we've already got that in there. The same with things like we're using pointers here, because we can say, hey, like, is the pointer nil? If so, then when we eventually have to set the flag in the bit representation, we can just go, oh, well, is adaptation nil? Oh, well, if it is, then we don't toggle that bit. So wherever possible, we try and like, I guess philosophically, like we think, okay, like Go gives us all of this stuff. You know, it lets us do all this kind of like, we have the code to program around it. So how much data do we really need to sort of like how much stuff do we have to expose? Because, you know, all of these fields, for example, like say we're looking at all that, right? But then if we go and look at the adaptation, our adaptation field, the way we represent it, we've got, you know, a few less fields there. That's the same deal. We can check for a nil slice, we can check for a nil extension. Yeah. So yeah, that's one of the cool things about Go, I guess, is that because the language is a bit sort of yeah, like we've got more than we've got in C or something like that. We can kind of use that to make the, how to say, yeah, like make our structures kind of easier. Yeah. So, yeah. So yeah, let's, what I'm thinking is let's just do a new thing. So let's go, how to do this, maybe just PES. I just don't like using these acronyms in Go. It doesn't feel very idiomatic. Maybe elementary strain? It's such a long name. Maybe just do this. Okay, so we'll go over here. Can we put that in there? Yeah. Okay, so we've got the ID here, and that's a single byte. So audio streams, video streams. Not sure what those things are. Let's just do that for now. But yeah, I'd like to, this is saying to me, hey, like some constants. Start code prefix, well, yeah, we don't have to store that. We don't care. Okay, packet length again, we don't care about that. The header. Header. Might want to just, and then the data. The data, see elementary, in case of private streams, the first byte of the payload is the substream number. Interesting. I might quickly look at how I implemented it before, but here, I mean, I'm almost tempted to do this and then just have the header in here. I don't know. I'm yeah, not sure. I don't even know if this is. Yeah, it's kind of tricky. I remember doing this the first time. You've got like the transport stream packet, and then you've got this like totally like this other packet that actually really does contain the audio and the video. This other stuff is like for, like for, the players to kind of almost like the metadata sort of thing. It says, hey, like I'm going to be sending you this much audio or video. Like these are the things that I've got available. This is the actual, almost like the real payload. A lot of the same thing. Maybe we can just go scramble. Is this scramble again? Yeah, so scrambling. This is a scramble again. Marker bits, or not OX2 hex. Yeah. Okay, so that's a non-optional marker, so I guess that's just to help us here. And then we've got the length. The pairs header. The header itself is optional. Maybe we do need a new type for PES header or something like that. Because then we can, I don't know. So the marker, scrambling. We've already got a scramble type. Priority is a Boolean. Data alignment indicator. It's called alignment. It's a Boolean. Copyrighted. Boolean. Original or copy. So one implies original. Oh, sorry, I just realized that I can't quite see. Let me put it over here. What codec have I got running? Is that pull up docs in Acme? I've got I think it's in here. Let me just double check. Godoc, yeah. And Godoc, so these are blues or corridors. Yeah, this one. So this is a, I'll link you in the, that's the executable. So basically, whenever I'm in like somewhere, like at the root of a Go module, I'll just run godoc, and then it'll serve it from that. It'll serve all the Go documentation from this module and also from the standard library. Kind of camera using, I remember you said it could do raw MPEG-TS over UDP. Yeah, it is. It's a Sony camcorder. No worries. Yeah, it's a Sony camcorder that I paid way too much for back when I actually had money. Yeah. It's a Sony... Travis, man. You're as bad as me, huh? Something useless. Okay. It's a Sony, I think it's an NX80. Just keep this over here so I can see. All right, so copyright. So copyright, it says one means below original. So I guess this is going to be one implies original. So let's just do original. Ooh. Okay. Present time. Okay, so this is. Yeah, I know. It was sort of like it was COVID, and I was like sort of a retail therapy thing, like right at the beginning of COVID. Yeah. Yeah. I don't know. But I don't even, I don't know. Like, yeah. Yeah. I should put it to use, but you know, yeah. Oh, nice. Titanium. Oh, hectic. Oh, wow. Oh, geez. These things are crazy. Yeah, yeah. Ooh. Oh, it hasn't got a hidden LCD. Oh, wow. Huh. Wait, hold on. Let me just... And it's a... And you can change the lens, right? Wow. Yeah, cool. My girlfriend, yeah. Anyway, okay. Okay. So, I'm just looking through these flags. So it looks like all of these we can... Yeah. Oh, geez. Okay, here we go. So this is, so if anybody wanted to see me like fail hard doing bit packing again, fucking today is your lucky day because it's going to happen. Yeah. Okay, let's, Oh, yeah, nice. Yes, you got that old like what was that lens mount? They had that. Yeah. Yeah, I actually just sold one of them. My dad had an old lens, like not super old, but I guess. Okay. So oh geez. Okay. So those are the and then everything else are just flags to tell us what is in the optional fields. So we're right at the beginning. So the first bit is going to be this presentation timestamp. So presentation timestamp. So this is, oh wow, it even like has a link for it now. So it's the number of ticks of a 90 kilohertz clock, which is what we've seen that a whole bunch of times already in Scuddy and in some other places that I can't remember. Oh yeah, in already this MPEG transport stream. I feel like what we need is actually a timestamp type. But let me just see how it's actually, yeah. So I'm just reading, let me just go there to show you what I'm looking at. So the above flags indicate that values are appended into the variable length optional fields, but they're not just simply written out. For example, presentation timestamp and the decoder timestamp, that's DTS, is expanded from 33 bits to 5 bytes, 40 bits. If only presentation's timestamp is present, this is done by concatenating 0010B. The most significant 3 bits from PTS, following the next 15 bits, 1, rest 15 bits, and rest, oh my fucking God. Okay, yeah, I remember this now. Oh. Yeah. Okay, so the bit representation of this is like a pain in the fucking ass, basically. We're gonna need a diagram. So this is PTS. So within a timestamp, say we have a timestamp struct, something like this. We're gonna do the type almost, and it's going to be like a this is going to the thing. There's a little what is it, 4 bytes. First 4 bits of PTS are 0011 and DTS are 0001. Yeah, so it's almost like a. And then we're going to have the actual, the ticks, which is going to be we're going to need to use a UN64. But the way this is represented is really fucked, right? So you've got I'll do our diagrams again. So 1, 2, 3, 4. Okay, we've got 5 bytes. Okay, here we go. So we got, not just simply written out, for example, presentation is expanded from 33 bits to 5. If only PTS is present, this is something 0010. So the type is 4 bits. So we go 1, 2, 3, 4. That's where the type bits are stored. So just those first 4. The most significant 3 bits from PTS, rest 50 minutes and 1. Oh my God. Okay. More people. Hey, Ubiquitum and Rebel Elder. Are we back? We are back to, haha, that's funny. We are back to scheduled programming. So we're programming, yeah. Very clever. Okay, so, look, fellas, we've thank you for following, everybody. We just hit 254 followers, which of course is very, very, almost very important on this stream. We just need one more follower, and then we've got 255 followers, which is a very important number for us. As every, there we go, 255. Okay, we've got 255, so you know what that means. Magic number 255. Yeah. Oh, we're up to 256 now. Okay, no, that's it. Well, it's still significant, but yeah. Significant, of course, but yeah, All right. So let's, okay, sorry. So this is going to be a bit tricky. So let's just focus on this. So we got, yeah, okay. So what this is saying here is that the PTS is going to be, for the type, we've got PTS only is like this, 0010, and then 1, 2, 3, 4. PTS and DTS is OB 0011, 1, 2, 3, 4. Right? So we've got a little, actually what we've really got are flags, right? So this, if that bit is set, then it means PTS is present. If that bit is set, that means that the decoding timestamp is present. So we almost need like, we could almost have like, has PTS and has like DTS or something like that, right? I'm not quite sure how best to represent this, but yeah, we'll work it out. Okay. So those is always going to be 0. So those are just zeros, it's saying. And then we've got our 2 flags for PTS or DTS. So let's do it like this. That's PTS and that's DTS, right? So if we've got, yeah. Oh, fuck. No, I fucked it up. Hold up. Sorry, give me a sec. Yeah, I'd fuck it up. The presentation time is spent from the most significant 3 bits from PTS. I told you if you wanted to see me struggle with bit packing, then you've come to the right place, because yeah, it's happening. I haven't even filled that 1 byte yet. Most significant 3 bits from the presentation timestamp. Next 15 bits. 3 bits from the presentation. How can it be 3 bits though? Yes. Oh, no. I've got it. Okay, I've done this wrongly, right? So, yeah, okay. Okay, we're going back. We're going even back further. Okay? We weren't even as far ahead as we thought we were just then. We're actually going back. Okay, we're going right to the very first bits. So we've got nothing. Okay. Yeah, I got it. Okay. I think I got this. All right. So we've got the flags. So these is always 0. If we've got a presentation timestamp, and then if we've got the decoding timestamp. And then that's it. Then we've got the timestamp. We've got the most 3 significant bits from the timestamp. So let's call that T for ticks or something. So 1, 2, 3. And then we have to have 1. Just has to be set 1. Okay. That's the first byte done. Easy. Next up, we do the next 15 bits. Okay? 1, 2, 3, 4, space. 1, 2, 3, 4. So that's 8. 1, 2, 3, 4, 12, 13, 14, 15, and then a 1 again. All right. And then we do the same pattern again. 1, 2, 3, 4, space 1, 2, 3, 4. So that's 8, 9, 10, 11, 12, 13, 14, 15, and then 1. So that's how we pack the timestamps. So we need to take our 33-bit and put it into this thing. Okay. So big endian from a little endian uint64. All right. That's the first 2 bits. Oh, that's this again. Yeah, but it's not. It's not that. It can't be 2, 3, 4, 5, 6, 7, 8. Fuck. What's the 0, 0 then? Oh, 2, 4, 5, 6, 7, 8. Okay, we'll no, it matters, yeah. All right, I'm not sure what these, have we got 33 here? 3, 7, 11, 15, 16, 17, 18, 33 bits. Okay, so Sammy writes in YouTube, 0, 0 implies not scrambled in the scrambling control. Yeah, but no, sorry. So this is only the timestamp. So this is I'm looking at I'm looking after the so after we've set all the flags and stuff like that, we're now looking into the optional fields. And then the first, well, depending on what's set from the flags here. Now we've got some other stuff here that we'll, yeah. So here would actually be like a timestamp, a bit pointed to a time something. I don't know. We'll get to that. I don't know how to do that well, but say we've got that, and then we're going to have a whole bunch of other things. Like we'll have the maybe that, I don't know, whatever, all those things. But yeah, it's weird. Yeah, 1 both present, 0, 1 is forbidden, 1 is only PTS, 0 is no PTS or DTS. The thing that's weird to me is that like you have it twice. So you have it in the flags that tell you, hey, like this is a, was a little while ago. So here's saying was poking at synchronizing multiple Twitch streams. After some with everyone discovered that Twitch injects a TS stream that contains a JSON blob with a timestamp when Twitch ingested the video, and attempted to know that this exists. Okay. Yeah. Yeah, there's a whole bunch of ways to, like, people do all sorts of crazy shit to sync, like to sort of, yeah, like send synchronization information around. Yeah. There was one, I don't want to give too much away because I'm pretty sure it's a trade secret thing, but there was a super cool, somebody gave a super interesting presentation that was about doing remote live sports commentary. So for example, you've got like sports commentators that are just like me, just sitting at home commentating like some like soccer or whatever, football. And so what they actually do is that they use what do they do again? They embed shit. What do they do again? To synchronize it, they embed like a weird marker in the audio. So they, like, yeah, some like impossible to, like impossible, not impossible to hear audio, but like it's sort of like invalid or something. And then that's very obvious. And so then whenever things are decoding around their network, because at that point you've got a whole bunch of like weird synchronization issues, right? You've got people from going all around the world over the internet, which is very much a not like tightly synchronized thing. Right? You can imagine like how many synchronization issues you can get. So, yeah, but they managed to like pull it off well enough for their particular application. Can't remember exactly where they do it now. Oh no, maybe it's also in the transport stream. No, wait. Maybe they weren't doing it in the audio. Fuck, I can't remember now. The very important thing was that in their software, they have to make sure that the time is synchronized. Like the system clock is with NTP. So from there you can get pretty good timestamps. Yeah, I actually think it's like, I don't even know whether it's a good idea or not, to be honest. It's just like super cool. Like, you know, it obviously makes sense, but yeah, it's, and that's just audio, right? There's no video. Very safe, yeah. I'm actually pretty sure they use the, I'm pretty sure they actually just use the timing in the MPEG transport stream in the end. Anyway, let's come back to our timestamps. So the zeros are just whatever. And these are see, so this isn't a good representation either. So with this one, it needs to be like the, there's a bunch of different information we need encoded here. We could do something like this. Don't really like that. Okay, so that contains all the information that we need. So we check for nil if the value is set or not, and then if we dereference, then we get our actual number of ticks of the clock. Yeah. and then from there, when we encode it, we can, well, rather, let's say when we're decoding, we can read the information that we need. So for example, oh, P is set. Oh yeah, okay, fine. And then yeah. I just still don't know quite how that works. Because here we're going to have, like this is, what about the rest of the bytes? So let's say we've got both presentation timestamp and decoder timestamp. With both the timestamps set. So how are we going to get, like, how do we encode the next 33 bits from the timestamp? Maybe we use those flags again. So maybe it's something like this. It's just exactly the same again. Maybe it's that. So encoded, say if we pack this timestamp, we could have, depending on what's in there, we could have this, that, or both. But either way, this needs to be set. That might be it. I might just do a little sneaky and look at, because I have actually solved this problem before, about a year or two ago. I'm just gonna look at my notes from an old project. Let me just check. Oh, sorry, just get Haiku4132. Hey, what am I making? We are doing a MPEG transport stream decoder and encoder. So MPEG transport stream is a like a media container format. Like the most popular one, I guess, would be like MP4 or WebM on YouTube. This one is used, was originally developed for like satellite and like normal terrestrial TV and radio, digital TV. So for example, like you're going to have actual like this diagram has, you've got a TV tower that's actually sending out shit to TVs. So that stuff has got MPEG transport stream in there. I actually saw the other day, this is a crazy fact about MPEG transport stream, right? Depending on where you are in the world, you may have, if you're in the USA or in Australia, we had this too, a cable internet, which is, like instead of having, cable TV. So instead of having a, like that thing, you actually had like a coax cable that would, that went around to all people's houses and stuff like that. If I remember rightly, the cable internet that came afterwards, so they wanted to say, hey, like we want fast internet, we want to send it around. The earlier versions of cable internet actually was transported by MPEG transport stream. The actual internet, like actual like IP packets were in there. This is crazy shit. That's DocSys, if anybody's interested. So I think I was DocSys 1 or something like that. I think actually used, yeah, it's actually crazy. Like I couldn't believe it. Yeah. Data over cable TV. Yeah. So, yeah. See, our old friend Scuddy. Oh, it looks like in Europe they had that too. Oh yeah, because in Europe I had a coax cable that was in the Netherlands. I had a coax cable from Zugo. Where was it? I really want to find this because this would just be like such a random fucking like thing to like, I don't know. It'd just be funny. The DOCSIS frame is first encapsulated in 188 byte MPEG transport stream packets. That is wild. So DOCSIS frames are in MPEG transport stream payloads. That is fucking dumb. That is crazy. So there you go. That's, yeah. I actually forgot about reading. I forgot that I read that the other day. Anyway, there you go. Let me just look at, there we go. Virgin in the UK did cable. Cable just didn't get the push because BT had the monopoly and owned all the copper network. Yeah. So only a few cities, mainly down south, that got cable. Ah, there you go. Yeah. Interesting. Yeah, yeah. In Australia, Telstra, that's like the BT, it was used to be called Australian Telecom. The Australian big monopoly telecom company, they also did all the cable as well. So for them, it was all very happy days. So there was Foxtel. It was crazy, right? So they did a partnership with like Fox News and bullshit, and Telstra. That was the cable TV service in Australia. It is called Foxtel. Still. Yeah. Crazy stuff. And thankfully all that Foxtel stuff is going away now because fucking assholes. Okay, I'm just looking for my old notes on transport stream here. Oh, is that it? Whew. Okay, just reading through, just so it's not too boring for people to watch, just because this should give us a quick, yeah. Sorry. DTS. And data. Marshall. I think I found it. Here we go. Yeah, got it. Okay. Okay. Give me a sec. Poor fucking hell. This is ridiculous. Okay, PES header fields, raw data. PES packet. Timestamp. All right, here we go. Oh, that's gnarly. Okay, all right. All right, almost got it, almost got it. Just looking at the code. Yeah, yeah, okay. I see how, oh my God. Yeah, look, it's not too bad, but the CRC PTS. Oh, I'm doing DTS. Oh, I get it. Okay, okay, okay. So, actually, it is like this. This is how we want to do it. So this, let me just do it in pseudocode. So we've got a type, we've got a timestamp. And then we've got the ticks, and that's a 33-bit int. And then we've got the, has PTS, and then we've got has DTS, or is PTS, is DTS. So that's 1 bit. And this is also 1 bit, like that. So actually it is just like, so it's actually like that. So that is indeed how you decode a timestamp. And then these markers just tell you whether it is a, how you should interpret them. So a decoder will read that and go, oh, okay, this is a presentation timestamp. Oh, and it's also a decoder timestamp. Okay, that's fine. Like, good to go sort of thing. Yeah. Cool. The reason for having these 2 timestamps, by the way, is because on, as you can imagine, like on old TVs, they weren't connected to the internet. They didn't necessarily have any like accurate internal clock. So you would send out the presentation timestamp, which is the, you know, like the thing that says, hey, like show this audio and show this video at these times, these frames, whatever. But then the decoding timestamp, I think, was there to actually help the decoder know what time it was at all, like as a kind of reference. That's my sort of rough understanding of it. At least from what I remember. So our timestamp is going to be, yeah, I guess like, yeah, going to have a transfer string timestamp, I guess, something. I'm not quite sure how to do it, but yeah, there's our thing. So let's put this into code. So it's going to type I don't know how to, maybe I can just do PTS bool, DTS bool. I'm not sure how to. And then this ticks is actually a uint64. Something like that. And then we're going to, okay. Whew. All right, so I think we've got that one optional field done. I mean, we haven't done anything, but I mean, we've sort of specified it, which is probably the hard bit. Because in our, after the PES header in this particular packet, then we'll have the optional fields. So we've got the header, and then we've got, you know, perhaps PES header, and then we've got the, so here is actually looks like this, the scrambling, yeah, here is actually like the header, and that's pointing to a PES header. So that may or may not be there. Like that, I think. Stream ID, length, PES header, yeah, that's it, right? The header and then a timestamp, which kind of looks like that. So let's just check we got everything. Original or copy, yeah, okay. Oh, and then stuffing we've got as well. Okay, so stuffing. I feel like the stuffing bytes, I mean, we should almost, the significant thing of the stuffing bytes isn't so much isn't really the, like, we don't care about the value, it's just the count. So I feel like we should almost just have that as an int or something, or like a, you know, uint8, or, I don't know, I'm curious to hear what people think there. Because the stuffing bytes are defined as the, like, they must have the value OXFF. So, I mean, yeah, it's really about the number of them. If we've got 0, then we've got 0. That's fine. 0 is a valid number. We have a uint8 there. Just an int, I don't know. I go through code editor. Yeah, this is Acme from Plan 9. Yeah. Using the plan on file. Yeah, that's right. Yeah, yep. It's a good link. And also in the, oh, well, yeah. And then on that page there, Haiku, there's a great video by the lead of the Go project, who just does like a walkthrough of the editor, how it works, how it kind of, how it kind of presents the text editing workflow and stuff like that. It's really good presentation. I'd recommend looking at that. Yeah, okay, so yeah. I feel like I want to do actually this. Yeah. And not only that, right? Not only that, but could this be just calculated at like, I don't even know whether we need to expose this actually. Export it, sorry. I don't know whether we need to export this value. Because it's just like implementation detail, right? Like it's only there if for whatever reason, when we pack everything up, it doesn't fit into the size that it should. I'll leave it like that for now, but you know. Well, yeah, you're right, actually. Yeah, that's true. Yeah, you can't. Well, can you? Say if you were to change it, right? What would happen? If you change the count, then when you do encode or decode, right? Like when you actually call the encode functions, you know, if you do a packet, then and you've changed stuffing, then you're fucked. Yeah. Yeah, but no, you're absolutely right. Like you actually, you can't use it is the point. Let's give there anyway. Yeah. Okay. Whew. Alrighty. So we onwards. Shall we try and now decode the a PES packet? Samir, oh yeah, oh sorry Samir, I didn't see a message. Yeah, but this is Acme, as you probably saw on the stream. Yeah, that's true, exactly. Yeah. I mean, there's a lot of stuff actually that I feel like I'm exporting, but I don't want to. But I kind of, I don't know, just yeah. If of course on real world projects, right? Like I'm like, don't export fucking anything. And then you just very slowly, oh, okay, do we need that? Okay, fine. Yeah. But that's when you're working with teams of other people and stuff or whatever, you know. And Elsad says, good luck. Thank you, Elsad. I definitely need some luck. Okay, let's try and decode this thing. So where can I learn Golang? right here. Nah. I think it depends how much programming you've done before and stuff like that. Okay. Yeah, I mean, I think then, I think Python or Go or anything, especially if you know, if you're just starting out, then I think either of those languages are great. Yeah. Depends on the types of like problems and types of projects that you're working on too. Yeah, that's also a great question, yeah. All right, yeah, so let's do this thing. So we're gonna just don't know how many. Yeah, I'm gonna have to do some kind of, because I can't remember how we check for the length of these things. We'll just have to be careful about it. Okay, so if I, okay, let's go. So we start with 3 bytes. Can be 0. Okay, so we need to have called the start code. Yeah, okay, so the 32-bit start code, well, it doesn't really matter. Okay, so let's go. If len of buff does not, is less than 4, then we return nil. Okay, and then we go, we need at least, well, actually it's 5, right? Because we've got the 3 bytes for this prefix. The stream ID is 1 byte, so that's 4 bytes. But then, oh no, sorry, we need 1, 2, 3, 4, 5, 6 bytes. 6. Okay, so let's do, let's read the next 3 bytes. So if, so the start code prefix is just 1. So let's store that in a constant, right? So let's just make PES. This is the header, PES header. Is there something special about this word start code? Sync word. Yeah, I say it's not start code. Like, it's not really relevant. Let's do 3 bytes. So why don't we just make it a fucking even 32 or something? Yeah. 1. So we can. I don't know how best to do this. So let's go prefix. Maybe we can just do Can I do constant arrays in Go? That's kind of what I want to do, but yeah. No, didn't think so. Okay, path to 4. I don't know the best way to, like, I know this seems really simple, but I don't know, I just kind of want to, yeah. Yeah. Oh yeah, do that thing. Yeah, that's an idea. Yeah. I don't know. I just no. I just want. I don't know. I just want like a way to check for the value. A way to check for a 3-byte value, which I guess is an array of 3 bytes. But I kind of maybe I should do a. here a type, is it? Or a ID? Oh no, sorry, it's up here. ID byte. Okay, so that's easy. All right, so PES PES dot ID equals 01 is 0, 1, 2, 3. That's 3. Packet length, okay? So now we do, is that 2 bytes? Oh, boy mama, 16-bit integer. Wow, lovely. Fucking our fucking lucky day. Packet length, so let's do P length. Big Kino. Hey, Big Kino. Why not streaming on Twitch too? I am streaming on Twitch. Yeah, there you go. Yeah. Right, like that, yeah, and then yeah. I hope somebody's watching from the our self-hosted stream, which it's there, right? The important thing is that it's there. That's the thing. Ah, yes, you are. Sorry. No, no need to be sorry. Come on. Or should I say, I accept your apology? Yeah, okay, this is tricky because like this length is actually, we actually need to store that. We need to store that ourselves. The reason why is because it, yeah, so this actually needs to be, the reason why is because you can have you can have a length of anything. Because for example, a video, like a video stream can have very, very large packets, but they're just fragmented over these 188 byte packets. We can actually see that in Wireshark. So when we go into Wireshark later, we'll see that the, we'll see the, we'll see it'll say like reassembled in packet so-and-so. This is where this comes in. So we need to store this length. And it's a UN16. And 0 means, so yeah, length. Yeah, so that should be, yeah. I'll just document it now. Follow 0 for the best we can use. Yeah, this is yeah, okay, we'll just, I don't know, for this in the packet after this field, yeah, I'm not sure. Okay, let's keep it like that, and then let's see how we go. I'm not quite, I don't quite understand what this length is. That's kind of why I'm writing the documentation. I'm just testing my knowledge. I'm saying, hey, like, can I put it into words? And if not, then I might not understand it. And right now I don't understand it. But that's cool. I think I'll come back, try and put it into words again, and then see if I can write it. All right, so we've got our length there, and here we can actually just assign it straight to the length. Okay, that's easy. Okay, length, great. Okay. Okay, now we're going to check. All right, the variable length. So I guess this is only going to be there if is how do I know that this is available? Only if I don't know how to tell whether this is actually available or not. If the PES packet length is set to 0, the PES will be I don't get this, okay? So I've got the length. If it's longer than, like, if it's 0, then, if it's 0, I guess it means that everything else is data. Yeah. So we only go into the PES header if it's greater than or equal to 3. Yeah. Which is what's written there, but I sort of get it now. Okay. Now we go in and try and get the header. So the marker bits. Okay, so let's, I feel like I want to reslice now just because, yeah, this is kind of where we're up to. Oh, sorry, I just got some messages. I see it. Big Kino says, I saw your clickbait video on Acme Editor. I must say most devs rely on answering AI rather than reading the docs. Oh, yeah, it's like, I think one of the things I wanted to say is that, look, like, it's not really about the editor, right? Like, it's about just seeing stuff in a different context. And the editor is, of course, it looks a bit different, but, I think seeing things in a different way is I think that's sort of what really happened, right? Yeah. That, and also, indeed, yeah, as you say, clickbait, yeah, like, I was getting so pissed at all that stuff, I couldn't do it anymore. Those fucking job descriptions are honestly, like I get, anyway, I'm gonna do it. Yeah. And then somebody here says, Oh, Puya Sharif, he says, hey, how are you doing? I have a question. I want to start learning Go. Do you have any good resources? Oh, look, I mean, as a very boring sort of first thing, I guess if you saw in the chat, Puya, then you can see Rebel Elder was had some good advice. As just a sort of boring start, I mean, I always think this book's good. Easy book. You know, just a great introduction. Another one just passed his interview. Oh, nice. Congratulations. Well done. How are you feeling? Yeah, cool. And got to go keep it. Okay. See you, Haiku. Thanks again. Thanks for stopping by. Okay. Let's keep going. So we got our... let's start reading this thing. So our... Not sure... Let's create a new slice with the... No, I don't know. Yeah, no, that's not quite right. I need to... The header length is length of the remainder PES header in bytes. Yeah, okay, so I don't actually know yet what it is. So let's read up. Let's start going through, because this is all 2, 4, 5, 6, 7, 8. Okay, so that's 1 byte. 2, 3, 4, 5, 6, 7, 8, 2 bytes. And then there's 3. Okay, so that's where we're getting this from. So that's good. But we need to make sure that we've actually got that many. So we need to go if... Let's do a check first, okay? So let's go if... Or maybe we can just check now. Hey, like, do we actually have that many? Ah, oh, fuck. No, because it can be 0. Motherfucker. Okay, we'll go here. From 4... No, from... We want to check that we're actually getting, that we actually have this many, that we have any bytes left in the buffer. So we've read up to byte index 5. So now we need to go like, you know, is the length of from 5 onwards greater than equal to the length that it's told us. So if it is not equal, then we've got to bail out. Okay, so we've got here so the header reports that, but we have that many. Okay, let's... Okay, something like that. So we'll get the... we'll need to do a type conversion on that, but we'll do that afterwards. So we're going to go like that. The length, yeah, that's the length. It reports this long, but we only have oh well no that's it, yeah, and then we're good. So we don't need that bit there. Header reports that we have that many left. So let's do it again. So pes.length, we have that many. Okay, and then that, we're good. Yep. Okay, so we're safe. So from now on, we know that we've got as many bytes as it's that we've been told. So we can very happily just slice away without fear. Okay, so let's go. So let's start reading. So we got 2, 3, 4. Is this right here? Let's just check. Because we read from we know we've got 5. So we need to actually check that we can get to 6, because I don't want this to freak out. This isn't right. We actually want to read from 6 onwards. So we need to check that first. So if len, oh wait, no, 6, no, fuck. Yeah, that's right, yeah. So length of buffer is Okay, so first we check if we've got enough. And then we check, first we check if we've got any, and then we check if what we've got is actually the correct number. Then, okay, now we're good to slice. And from here, I want to maybe just reslice. So I'm going to go here, and this is really cheap operation in Go because it's just a slice, not actual allocation. So we go from that onwards. Okay. Here we go. So we're going to check the first two bits. OX 1100. What is that? No idea. Oh, that's, yeah. So that's 110. There we go. C0. OX C0 is not equal. I'm comparing len buffers if they're importing valid bytes to len buffers. Oh, no. Nice. Whoops. Yeah. I should almost yeah. Nice. Good spotting. Thank you. Yeah, it could be tight. This needs a bit of a, this stuff here needs a bit, yeah. Okay, so what are we checking for here? We're checking if the value is not then we're not happy, right? Because the we want those two bits to be set. Wait, how do I check the bits are toggled? So this is, no, wait, or, wait. No, that toggles it. Now I want to check if they're set. Yeah, that, yeah. So this is going to be the decode the header. Marker. Okay, and then, all right, so then we move on to the next thing, scramble control. Okay, 0, 0 implies not scrambled. All right, so let's, can we store that just as is? Because we have a bunch of go doc scramble. fuck's sake, so we can't use the same values. Hey, this isn't right either. This should be. Sorry, I'm doing a bit sloppy. Oh no, I think that's right. Yeah, OXCO. No, that's right. Yeah. And then the next one we want to check for is the next 2 bits. So that's OX30. Yeah. So we're going to do pairs dot. Is this the header? Yep. OX30. Why doesn't it? Why am I not convinced of the value of that? I don't. Should fucking print that out of my wall. That's what I really need. And then and it's going to be 3. Yeah, that's right. Yeah. Yeah, I was actually thinking of doing that. Yeah. I've done that before too. Yeah, maybe I should use the binary. It's a good idea. Yeah, maybe I should do that. Yeah. Anyway, we're good. Okay, just that. Okay, that's fine. And then this actually need to change. So this has got to be. Open this up. Let's copy this. Have this over here. Down a bit. This is going to be scrambling. It's just going to be. I'm just going to set as a UN8 for now. Okay, h.scramble. Okay, next up is the priority. So that's 4, so 5 bits along. So 5 bits along is, yeah, let's do the binary, yeah. If hbuff O and OB 2, 3, 4, 1, 2, 3, then that's true. Okay, other flags, data alignment. So that's a flag as well, easy. Okay, so if hbuff O and OB 4, 1, and 0, then again, h dot alignment is true. Copyright. Okay, so this is telling us that it's copyrighted. Or copyright, just do copyright, that's easier. It's true. Implies copyrighted. No, I like that, yeah. And then finally, because it's an original. Okay, awesome. Okay, toggle to all our flags. Let's keep going. So now we've got our timestamp indicators. So 2 bits. O1 is forbidden. Should we check that? O1 is forbidden. Yeah. So what that means is that you can't only have a decoding timestamp. You must have either, yeah, that's it. What we could do is start to say if we see this flag is set, we could, I don't know whether we need, like we could almost skip ahead, right? And then like get the, yeah, because those are the flags. So yeah. Because we're not really storing the value of the flags. We could just do it, okay, so flags is that we know for sure. Okay, and then we can, let's just see, so 2, 3, 4, 5, 6, 7, 8, yeah. Okay, so now we can go the length again, so h length is that byte. And then, yeah, and then that's, yeah. So we could start reading from the h length. So we could reslice to get the sort of the optional fields and the stuffing. Because we've sort of got this, but then we really need to, now that we know the end bit of it, we could do that. So we could say, okay, hbuff is actually, is just reslice, so hbuff from, it's 3 to 3 plus h length. Now we've got a fixed size, we know exactly where we're getting it from. Yeah. 3 plus, is that right? Yeah. Okay, and now we can start. Now we can go down and start checking the flags and start decoding the stuff in the optional fields. So our first one we can do is the timestamps, because that's the hardest one. Yeah. Okay. So let's go. So let's go like if without the ifs. Yeah, sure. Please don't hate me. The priority align, copy and reflag we set without the ifs. Oh yeah. So like this, right? Nice. Yeah. And then yeah, and then because we're storing the Boolean, so we can just do greater than 0, right? Nice. That's good. Beautiful. Yeah, no, that's good. That's good. Oops. Right. Okay. Yeah. Interesting. Yeah, and I feel like that's just like... Yeah. It's good. Yeah. Cool. Thanks. Let's close that. I'm gonna put this up here. All right, let's try again now. So we got the edge above, okay, and then so now we can go if. So let's see what we've got here. If we're checking if we've got timestamps, so we need to check which ones we've got set. So if two, 4, 5, 6, 7, 8. So the next 2 bits. So 1, 1, 0, 0, 0. Right? Yeah. So let's just see. So if that. Okay, we know that we've got timestamp. So let's do that. Timestamp equals tstamp is okay. Now we can check we can assign these values using our very new trick thanks to Irving. Right? So we can do the same thing again, right? We can go .pts equals and then we go B, and then we know this is if the first bit is set. So it's just AB1 and then 1, 2, 3, 4, 5, 6, 7. Is that right? And the same thing again. O, 1, 1, 2, 3, 4, 5, 6. And then present, 0, 1 is forbidden, 0 PTS. Yeah, I think that seems right. Oh, fuck. No. Wait. Not sure about that. I'll need to check because we're going to be getting that information again in the timestamp. But yeah, let's see. Okay, so our timestamp is 5 bytes. So we're going to need 5 bytes, and we're going to read the timestamp out of that. Our timestamps. Yeah, so the what that means in like the real world is that you can only have like really it's something like this. If we'd check here, so we'd say if tstamp, if not tstamp.pts, we'd really need to error out here. Something like that, yeah. And then, that's as Spooks said, yeah. In the real world, because you need the presentation timestamp always, and the decoding timestamp is only like maybe there to help the device. But without the presentation timestamp, the thing doesn't know how to time the playback. But yeah, exactly. You can't only have the decoding timestamp. So this would be, yeah. So it'd be like, yeah, like. This is getting a little bit, yeah, a little bit sort of nested here, but we'll, yeah. Yeah, that's right, yeah. Well, yeah, because one's saying, hey, like the field isn't even present, so whatever. Oh, sorry, I got more messages on Twitch here. Morning, bud. Hey, I've been using Acme a little bit, been quite fun. Couldn't get watching every working correct, but otherwise, whole different world commented. What OS you on? What issues did you have? macOS, when I do watch it, I'm going to run them, just not running it when I put it in can't be closed. Yes, okay, that is an issue with the latest version of, if you're there, Guitio, basically, the latest version, 0.0.5 is broken. The previous release, 0.0.5 is okay. Yeah. I actually found that out with, no worries, yeah. Yeah, I found that out with Trav GM, yeah, a couple of days ago. No worries. Yeah, it was funny because we just started and then it was like, okay, like, yeah, just install Watch, install Admin Go, let's see how we go. And we're going and he's like, it's not working. And I said, what do you mean it's not working? Like, what the fuck? Yep, so there you go. it's not a great error, but I'll yeah. Only bad if DTS is there too. Yeah, that's yeah, but we're in that here. So this is saying, hey, there's a timestamp, and then we see which ones are present, and it says timestamp present, but we're missing a PTS. So that's an error. So yeah, only DTS, like you know, only DTS and no PTS, maybe something like that. Okay, let's work out how to decode this this bad boy. So we're gonna have our so timestamp here. Okay, so let's go. We got. So this is a, how are we gonna do this? 33-bit thing. I'm gonna need to return a uint64 out of this. This definitely calls for a new function. Okay, so let's do yeah, and this has got to be out of a thing of 5 bytes. Okay, so we're gonna start reading it, right? So we've got 0, 0, or whatever, maybe it doesn't matter too much. Let's, again, see, we're doing this again. So it's kind of weird, like in the actual timestamp, we're gonna have these set. So we're gonna have it in the flags, in the header, but we're also gonna have it in the actual timestamp for some reason. Yeah. So maybe, yeah, I guess we should check it just in case. So really we're gonna get this shit, right? So that, an error. So now we need to refine the logic as you've just said. Yeah, so here is going to be if dstamp.dts not that, then something like that. Okay, now we're going to start reading our integer out. So we've got 3 bits here. So where's our first byte going to come from? 1, 2, 3, 4, 5, 6, 7, 8. Oh. Okay. Let's check whether this value is actually, let's check whether that bit is toggled, because if it's not, then we also need to error out. So we're going to go if O and OXO1 is greater than 0, then we need to error. I don't know what thing is going to do. Just do that, like, you know, I'm not going to, I'll do that in a, I'll come up with a better error message there. Now we're going to extract all our bits. So our first byte is going to come from that ORed with that. 6, 7, 8. Okay. So let's just get a byte first. Okay. The byte is going to be value of A. And so we're going to extract these 3 bits. So that's OB 1, 2, 3, 4, 1, 2, 3, and 0. And then we need to get the next from A1. So we could actually do it in 2 lines. So or equal, and then we go A1. With the, so we want those bits now. So that's, all right, so 1, 2, 3, 4, 5, and 1, 2, 3. Yep. So that's the first bit of our integer done. First byte of our, well, the first 8 bits of our 33-bit integer done. Now we go again. So V2, I don't know. This is bad, but let's do it nice and slow. I'm gonna actually have a comment which actually has this here because this is obviously like super important. So yeah, this definitely necessitates a diagram. Something like that. Okay. That'll come out as like a proper diagram afterwards. Okay, as I said, let's read the byte from index 2. So this is just going to be pretty easy. That's going to be the first 7 bits are going to be and then masked with so OB and then 1, 2, 3, 4, 5, 6, 7, 0. And then just so we've got 7 bits there. Oh, actually, sorry, no, you know what? Sorry, before we get going, let's check that bit there. Okay, so if A2 and OB is equals 0, it should be equals 0. Yeah. Same thing. Okay. And then, yeah, okay, we check that, and then let's go again. So we're going to just read one bit from the next byte. 1, 2, 3, 4, 5, 6, 7. Ignore everything else. Okay, cool. Whew. I feel like I'm missing some bits or something. Oh, no, we're all right, yeah. Okay, B3. So, okay, and then we're gonna go OB. So now we're going over, we're just gonna read these bits here. So 0, 1, 2, 3, 4, 5, 6, 7. And then, again, the OB and 1, 2, 3, 4, 5, 6, 7. Okay. And then, so we're getting, and now the next byte is 1, 2, 3, 4, 5, 6, 7, 8. Right. So we're getting, that's a byte there. Okay. And then the next is just going to be 6, the remaining 6 bits. So I suppose we should check now the last. So B4. So bad. Is that right though? Have we got enough bits? Yeah. Yeah, we got 33, yeah. I think. No, we're out. I think we're out. We're missing something here. Not getting 33 here. One, two, three. One, two, three. 4, 5, 6, 7, 8. So that's our first one, right? One, and then yeah, okay. So that's 8. 16, 24, 32. Huh? 15 is 30, 33. Why am I not getting 30? I feel like I'm not getting 33. One, two, three, 4, 5, 6, 7. Okay. 6, 7. Yeah, exactly. Yeah, yeah. It has to be. Yeah. I'm just miscounting or something, right? So that's our first. Yeah. So 3, and then. Okay, we check if that bit is set. Okay, B2. All right. So we're gonna go. There. It's here. It's here. I'm not reading these 3 bits. Sorry. Yeah, that's it. Yeah. I'm not, yeah. I need to read the 3 bits out of A1. I'm not doing that. So it actually starts like this. So B2 actually goes A1, and then those are zeros. 1, 2, 3, 4, 5. Like that. So that's byte 1. Like this is sort of B, like B, and this is B2. 1, 2, 3, 4, 5, 6, 7, 8. Like that. So that's, yeah. So then we go 2, right? So 2, and then we're going to read, we need 5 bits. 4, 5. One, 2, 3, 4, 5. There. And then we need to, yeah, so shuffle everything along. So we read, right? So we're checking, yeah, we check first and then we go, yeah. Oh, okay, so OB, yeah. Now this is going to be fun. Now we're going to read the next, just 2 bits. Fuck this thing. Okay. Now we've read A2. Yeah. A20001. A2, yep. Okay, next up is here. So we've read, fuck, where are we up to? So we haven't read these 3 bits. So we haven't read there from A2. So we need to read, is that right? Those 3 bits, is that right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. No, 0, 0, 0. 2, 3, 4, 5, 6, 7, 8. Yeah, okay. And we've checked that. Okay, great. So this is now going to be from A2. And it's only going to be those 2 bits. So we're going to leave the check bit, and we're going to go 1, 2, 3, 4. Like that. Yeah, there. We're reading these 2 bits. These 2 bits we're reading. Okay. Go back down to A3. Okay, A3, we've read 2, now we need 6 bits. 1, 2, 3, 4, 5, 6. Okay, let's read 6 bits in from A3. One, 2, 3, 4, 5, 6. Okay. There, now we've read 8 bits. Okay. Now we read the next 8 bits. Oh, well, let's do a check again. So we're now just up to A4. So if A4 and OB this thing again. We could probably do all of that checking at the top. Yeah. Oh, yes. Thank you, Spooks. Yes. Thank you. Yeah. Good spotting. I would be very, that saved a lot of tears just then. Yeah, lots of tears. All right. Okay, so now we're doing B4. Sorry, now we're up to A4. Yeah, absolutely, 100%. Okay, we're doing that check bit is there. So checking A4 is, okay, fine. All right. So now we're going to read, what have we got here? We've read A3. We've read 6 bits apparently. 1, 2, 3, 4, 5, 6. So we need 2 bits. Okay. There. Okay, so there's 32 bits. I didn't mean to press enter, I was typing out loud. Wait, do you mean... I don't see any. Oh, okay, cool. No worries. YouTube chat is relatively busy, yeah. Let me get that. Yeah. Oh, yeah. Oh, yes. Oh, man. Spooks is like the best debugger. It's good. The tear saver. The headache fixer. The future headache, like, preventer. I don't know what each... No, I think in this context, it sort of means the same thing. But yeah, that actually, yeah, right. That's actually a good way of representing it, yeah. Yeah, because then you can just like, yeah, do it all in one go. Certainly that would be clearer, yeah. Yeah, that's awesome. Nice. Yeah, let's you've influenced it. There you go. Yeah. If you, yeah. Damn, I've actually never looked into that. Yeah. See, and this is the thing, like, this should remind you of TCP because, like, this was sort of, this is like TCP without TCP, right? Like, this is, yeah. This is why you can sort of just like broadcast this. Yeah. It's true. Yeah, they do wish. Yeah, I know. I'm so close to disabling that YouTube chat, but I was actually going to do it today, but I forgot. So I don't know. Yeah, sorry. I don't mean like disable YouTube chat. What I mean is like, because having two chat things going, I've got one in IRC and then the other one I've got YouTube chat, but that's up like in a browser window up on the other computer. But but Spooks, yeah, exactly, yeah. I've never thought about it. Like I've thought about that, but I don't know. Like it's somebody explained it to me like that. They said, "Look, I was doing this," and one of these senior guys said to me like what the fuck, like what is all this shit? And he goes, he says to me, "Well, Ollie, because this was, you know, there's no compression. There's no, like, there's nothing to tell you that it's in order or not. If you imagine it just being like shot out of a satellite or shot out of an antenna sitting in an old fucking metal big tower, that's all that's sending it out. So something needs to do that somewhere. And in this case, it's literally just like sitting right here. So yeah, it's kind of interesting. Yeah. Okay, so there's our 33 bits. We had other kind of fun. Absolutely, yeah. Oh yeah, no, yeah. It was, yes. Fun. Fucking poor Plan 9 being neglected from the Go project, hey? Now, now Irving, you've actually, yeah, let's do Irving's nice trick for the check bits. So it's going to be up here, right? So one, is that, right? Because we're checking if 0, 2, and 4 would that be right? Yeah. Okay. Yeah, and then here would be like, I don't know how to describe this though. Do you have any tricks on how I would describe that? Something like the check, you know, the check bits not set. I don't know, that feels too low level. It feels like, I don't know. Feels a bit too... Rebel's also usually good at this kind of wording thing. Yeah, integrity, yeah. Yeah. Because this just means, yeah, yeah, yeah. Let me just do that. I do try and want to, maybe corrupt timestamp. Yeah, the thing is that I haven't got the, what I could do is bring up the actual MPEG transport stream, like the official spec. I never used it just because I guess I don't know, I guess for the task that I was doing it for initially, and they wanted something like very, very, very quickly. Yeah, it was a crazy project, but yeah, they wanted something done ASAP, and so I was like, okay, like fuck, I can do it, but you know, yeah, it is, yeah, bike shedding, yeah. Let's just do corrupt. I like that. Yep. But yeah, that's awesome. Thanks. Okay, so right, and then this, and then we're gonna go. Holy hell! What's this? Fuck, that's what I'm asking too. Now look, this is basically to detect like if you send out a you know, like radio waves, sending out TV signals over you know, over like radio waves, then this is a way just to check that the timestamps haven't been corrupted. So that's this shit here. Yeah. Just because if the timestamps are wrong, then that's like very bad. Because then it what happens is that playback can just fail, can like permanently fail then. And this I've actually seen in the real world because maybe it's worth describing a real world problem that is actually like quite common. Yeah, it is. So it is for synchronizing, but it's not just for that. It's also like if you can imagine back in the 90s, like digital TVs and like digital set-top boxes, they had basically no computing power. They had very little buffering, that kind of thing. So, and even today, it's actually still the case, right? So if you go to like any like smart TV or some kind of like mobile phone or some kind of dedicated like embedded devices that do like MPEG stuff, if the playback gets out of whack, it's hard to find sync again. So it kind of needs to decide like, hey, you know, it's time for me to like, you know, just throw everything away and start again if you get the times wrong. Because, you know, the actual underlying video, audio streams, stuff like that are actually quite big. And some of them are quite complicated because you've got like, you need a whole bunch of context, you know, for some of these codecs to, you know, for them to actually have something visible. So the timing at this level is super important. And we're actually talking before, MPEG transport stream was actually used to, is actually used in cable internet. So the earlier versions of cable internet, like the DOCSIS, like the actual like frame, the like data frames were transported in MPEG transport stream packet bodies. It's like totally fucking crazy. Yeah. Yeah. I know, it's like, I was like, well, no way. I read it and I thought, no, it can't be. And then I thought about it and I thought, well, actually, like, yeah, yeah. Because that's the data that they were all, that's the information that was being transmitted across these cable, you know, like coax, like those cables. Yeah, crazy shit. So yeah. Wilder. Okay. So what we want to do now is we've got a... Must have said we're already rated good for that if we can transmit TV. Yeah, yeah, like absolutely, yeah. They basically had these high bandwidth, like physical cables that were going to people's houses, and the cable companies were already making like a fucking shitload of money. So, yeah, for them it was just a bonus, right? Yeah. The other chat is on Twitch. That's this one here. Oh, it's in the YouTube thing, I think. Oh yeah, no, not running there. Yeah, but I mean like in the let me try it. Sorry, I can't type. Oh no, wait, I can type. Oh, I've got my keyboard here. Hold up. Oh, it doesn't show up there. Is that it? Untangle code? Yeah. Yeah, right. Yeah, I don't know how it's all laid out on the YouTube thing. Yeah, cool. Maybe, do you think I should put it in the bottom banner thing? Cool. Yeah, it is. I thought it is getting muted in the future. Well, I don't know. I just, yeah. I'll need to, oh, I see what you mean. Yeah, because if it's getting muted, then I can put like chat and then the thing. Yeah, okay, I see. I don't know. I'm not sure actually how to balance the, I don't know. But yeah, this is running IRC and I've got it piping into, I've got a little command that basically just, yeah, pipes the chat into Acme. Okay, let's get back to this. Now nobody knows who I am. Oh yeah, because the full name. Yeah, I see. So, you've probably got a good Irving. You've probably got a good. You've probably got a good idea of how to nicely turn this stuff into a. Could I do something like the tix is uint64? Could I do something like can I do the or, you know, can I go like I can do bit shifting there or something? Maybe I should just append them all into a yeah, sorry. In a previous the last time I did this, I did something like the timestamp.tix is, and then I would grab each byte, turn it into a uint64 and shift them along, like a long way to kind of manually make a 64-bit integer out of these 5 bytes. So something like probably could do the same again. Just start, you know, like going down. Equals, and just start going along. So the first one would be 33 bits, so it will be B5 shifted to the left 30, you know, like 30 something times. Yeah. Now I just realized, yeah, like that, yeah. Yeah, I guess that's what I did before, yeah. The only thing is that I'm just looking here. I just realized that I think this is incorrect because I don't want that, you know, I want the bit to be shifted along one. Don't I? I actually want this. Or something. Don't I? I think the others are okay because they're actually aligned. Oh, fuck, yeah, no, you're right too. Yeah, the 3, yeah. Yeah, all those, yeah. Yeah, that's right, yeah. So all of them is 1, yeah. Or, I mean, would I do this? Yeah, exactly. Or could I just shift the bits at, like, could I do this? Equals, you know, shifted 1 or something like that? And then do it for all of them? Would that be clearer? Just because then we've done all the check bits and then we assign everything and then we're... But I think there's value in having the input immutable. Okay. Yeah. Good point. Yep. No, I agree. Yeah. Makes sense. Yeah, exactly. Because it's very visual and you can be like, oh, like, why is it? Why are we shifting? And then, yeah, no, it's good. Okay. So we do this. I actually think Go format does this for me, but I don't know. Oh, well, it actually didn't do it. Yeah. Okay. Yeah, exactly. No, but we shouldn't need to worry about the precedence. It should, like, we shouldn't need to think about it. We just make it explicit, especially with this weird shit. Okay, so we're going ticks. Yeah, so now we can just start assigning stuff. So we're gonna go UN64 of, so this is, we're going from, we need to do a conversion from big endian to little endian as well here. So I guess we're gonna go from, because, well, at least because, I mean, you know, we're going to, yeah. I'll have to work, yeah. That's, yeah. So you could put all the values into a car array and cast that to N64. Wait, you can do that in C? Holy shit. Wow. Yeah, see, like, this is when, it's funny, because, like, I've actually barely ever done C, and so, yeah. I don't think you can convert it because it doesn't know the endianness. But what I feel like I could do is I could do like a, you know, like a tick buff or something like that. And then this is actually an array of 8 for a uint64. And then I would just do this. And then from there I can do the then I can do binary.bigendian. You know, something like that, and then it'll do all the shifting and stuff like that. So I think if I do that, I set it into the array in the order it should be, and it just does the shifts for you. Oh, really? Oh, so I can actually just convert it. So I can just say, like, I can just get an array of bytes and just, like, a slice of bytes and just, what? In Go? Huh, never knew that. Oh, okay, yeah. I think, no, well, yeah. I'm gonna do, yeah, well, actually, I mean, yeah, let's just check really quickly. Let's go, I think, oh, no, I've got that already. Okay, so let's say we've got, let's go, you know, go something like that, and then let's go the uint64 of B, right? So I'm hoping that, I mean, yeah, there we go. Yeah, cannot convert B. Yeah. Yeah, and that's how I've done it everywhere else. So in the SCSI and in, like, some other places, I can't remember. Yeah. So this is, this is why I've made this little buffer here. So it's going to be, right, I'm going to start going down. So B, O, and you'll see where I'm going at, getting at. So B, and then this is, and then last one. So 0, 1, 2, 3, 4. Yep. And then we endian dot uint64 from this, and then that's it. Now what we do is that enough for that, and then we got to change all them to be, okay, Acme Magic, anybody? Okay, so we're going to change every B to tbuff, but we can't change every B because we've got, you know, B0 and all that. So what we're going to do is we're going to extract the B and left square bracket, and then we're going to go chain, and I'm going to extract B, and then I'm going to change B to tbuff. Woo! There we go. Actually, I'll keep that there. That's good. All right. So that hopefully is okay. Now this is, thankfully, this is actually pretty easy to test because yeah, we've got a whole bunch of you know, tooling to extract the timestamps out of MPEG transport streams. So that's in Wireshark and in FFprobe and all that. So that's cool. I think now we're okay to read the finally get the timestamp out when we're, you know, reading a single packet in. So we've got oh yeah, no, good. I thought the lag was out. Mm-hmm. Yeah, cool. Okay. Let's just thinking how to. Oh, no, fuck it. We'll just do this. Okay. A. All right. So there's our right, and then we. Yeah, I guess that's that done. Oh, well, I mean, we need to return then. So h dot. So we could actually just do here h dot timestamp. Oh no, it's a like that. I don't really want to do a pointer, but anyway. Ah, yeah. No method scrambling. Cannot use nil as timestamp value in return. Ah, yeah. Cool. Okay. I'm interested maybe in. So. Yeah, so the next thing would be probably worth getting like a few test cases and just like having some tests for this function, because yeah, that's kind of an interesting one, isn't it? So we could get some ffprobe does this for us sort of. So if we go into here and show packets, it's an interesting flag of ffprobe, and then we can go TS, test data. We can read from Big Buck Bunny. Woo. There's lots. So yeah, we're going to be getting those. Let's test for those values. So what we could probably do is just find the first packet that has a timestamp in it, which may well just be the very first one, but I'm not sure. Nine zero five. But yeah, let's write a little test for that, because that's, I mean, some tests, because that's pretty hairy. Okay, and then what we're going to do is just quick. Oh, don't know what the. Okay, that guy. Okay, and then we're going to go. Just keep reading the packets until we find one that has a timestamp in it, and then we'll just do that one test and see what happens. Oh, sorry, no, we're not ready to do a test yet. We need to finish reading the rest of the PES header. My bad. Okay. So, optional fields. See, I don't know how to see these, like the whatever. So these flags tell you, hey, like there's an ESCR, there's additional copy info in the optional fields, but I don't know what they look like. I can go into the spec, but I'm kind of thinking that like I would just maybe just store them as bytes for now, because yeah, and then just as time goes on or whatever, we could like slowly work through decoding and storing them as kind of more meaningful values in the struct, like more meaningful fields in our PES header struct. So we've got here the timestamp, but then we've also got like, we could even just have a field that's called like optional or something, and then just a slice of bytes. So this is just, you know, something like that that is, that we don't know how to decode yet, right? Or something like, yeah. Yeah. So then when we are in the header, which is all of this stuff here, and then what we do here is reslice, because we're finished with those bytes, so we can just reslice and get rid of them. So that'll be of 3 plus 5 plus 1, right? No, 3 plus 5. Yeah. So we're finished with those bytes, and then the rest we can just say the h.optional equals that, and then we can return. Yeah. Okay, so let's return our PES. Okay, here we go. Not so happy with this fucking around. I feel like, I don't know. The 8 bytes tell you how many remaining optional and stuffing there are. What's that 8-bit? And you have a bad frame. So if the rest of the size doesn't match, oh, the 8 bits tell you how many optional and stuffing there are. If the rest of the size doesn't match, oh, okay. 8 bits tell you how many. Oh, here, yeah. Yeah. Yeah, so that'll be the header length. Yeah. So, yeah, I guess right now we're not really, yeah, that's true, yeah. So here we're not really doing anything with it. I guess, like, the idea here is, I think, is to say, okay, well, we know exactly the bounds of the PES header, whereas before we didn't. So before we just knew, okay, like there's going to be, is that right? No, that's not really right, is it? Because we can just read it straight off. Yeah, actually, yeah. So maybe we could simplify. Could we get this to be, you know, like the, yeah. Because we know that the value is there. Right, we check for the marker bits, and then we read all scrambling, and then eventually we get the header length. Yeah, probably. So we could kind of go and yeah, that's true. Oh, wait. We're being paranoid. The most I could do with that info without going into the spec of the option was a bit of check if the data is too long or short. Yeah, okay. I see what you mean. Yeah, because here, yeah, I see, because I'm not using it anywhere. Yeah. And also, well, what about here? Oh no, because there's stuffing as well. Yeah, so I could have, okay, I see. So I could do this, right? Say we skip, say we skip the length. Yeah. 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 So we could do something like, we'll say we've got the flags, okay, that's all right. And then maybe like that. And then that's it, right? Just like that. But then right now we're not checking, is it worth checking the, do we still want to check the length? For example, say we get, the length is, where's it from again? 2, 4, 5, 6, 7, 8. 2, so that's 2, that's 1, and 2, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's 1, 2, so it's from 3. Right? 2, 4, 5, 6, 7, 8. 2, 4, 5, 6, 7, 8. There's the flags. Yeah. No, wait, I feel like I got this wrong here. Doesn't feel right to me. Oh no, sorry, yeah, that. Oh yeah, no, that's right, yeah. Yeah, the length checking, yeah, it's almost, the length, it doesn't really, if the length is greater than, yeah, then we check. So we have that initial thing just to make sure that we can move around as much as possible. But the header length, yeah, we're not really doing anything with it. There is a CRC, but I think it's maybe there or maybe not. Yeah. So I guess if it isn't there, yeah, then at least you've I guess, yeah. Oh yeah, or even if you don't get there, even if you yeah. I see what you mean. So it could be something like, that you've got the length of the header and then you don't even get to the CRC, so you're not sure whether you, yeah. But man, so does the length of the PES header in bytes? Yes, it's just everything. So it's optional plus all that, plus the stuffing. The thing is that we already. No, I know. Okay, I know. Okay, so yeah, I've got it. This is okay because it's like this. So we want the length there so that we know perhaps how much data is left, because there can still be more data, like there can still be sort of a payload. So we want the length of the header so that we could say, oh, well, the optional stuff is going to be this long and the stuffing is going to be that long. That means that we can, we know then how much is left for the, how much is left for the actual payload data. Yeah, so that'll, yeah. So actually here, yeah. So here it would be h length we'll just do int of, right? No, it's good. It's good. No, it's good. Like I actually test that. I'm like, oh yeah, is that right? Yeah. Because then we can go see, because right now, if I were to set this as optional, that would actually be incorrect without reslicing or without checking where the actual, without setting the bounds of the header. Then the optional isn't that, right? So this would be, I think the easiest thing, so we know we've got 3 there. I was definitely doing that, yeah. And you know what? I actually remember doing that before. The last time I did this, I did that, yeah. I remember running into it. I was going, where the fuck is, where's my actual video? And then, yeah, it was gone, yeah. Well, like it was there, it was just, yeah. I remember doing this. Okay, so now we can go, what I want to do instead though is actually maybe do it right here. So h length. Oh, well, there, and then it's going to be the 3rd. Right, so maybe I'll read it from here. Right. 3. 6, 7, 8. Like that. And now we're good. Get rid of that. So we do H optional, and then we want to maybe we need to get the data, the payload in. So we're going to read from all of that, and then I don't know how to handle this here. We could re-slice here and say, well, now buff is the, equals, 6 plus. But that doesn't, I'm not so sure about that. Do it at the end, maybe. So that we know that we're, so that, and then here we can just say, yep, and then everything else that we've got is in the, oh no, actually here would not be that, it would just be h dot data equals. Is that the word we use, data? Yeah. Oh no, sorry, no, it's not even in there. Heading, stuffing? It would go really down here. Then we'd say, because the length can be 0. And if it is, then it's all data, however much we've got. So that's valid. So here would just be, we'd re-slice down here because we've consumed a whole bunch of bytes from the buffer in a sense. And then, and because then later there'll be more, right? Like we're going to be, doing this, and then maybe we'll read more, and then blah, blah, blah. And then at the very end of it all, we can do that. And then we can say, okay, is just the remainder of whatever's in the buffer. Then I think we're happy. So this is actually the PES data. Like that. Then I think we're good. Yeah, this is a bit, this is the stuff that we don't know. Maybe instead of it calling optional, we could call it optional and stuffing. Because we don't know. Okay. Decode PES. Now, I can't even remember when we're meant to decode the PES. I know there's some kind of marker somewhere that tells us, but fuck me if I remember. Oh, sorry, Great White Accelerator. Is there an RFC? Yeah, there is. There's a spec document. It's I think it's linked from that Wikipedia article. So if I go to, and actually I think I put it here, specified an ITU, this thing, H.222.0. So we've all heard of H.264. Well, this is H.222. So I think it's that thing. And I'm pretty sure there's like a PDF that, you know. Okay, sweet. So are we good? Are we good? Are we good? Okay, let me just quickly check in my stash how I checked. Is PES payload. Okay, so apparently so when we decode, so we're in our big fat, you know, up here, we would reach into the payload and we want to search for the marker bytes. The marker bytes are this sort of prefix that we've got here. So that's PES header prefix there. So we'd go in there and just give it a go. So what we do here is, now I'm not super sure that that's like, I'm not like really, seems a bit dodgy, but I mean, let's just say that that method of checking if there's like a PES packet in the MPEG transport stream packet, that's working right now on real TV stations. So I guess it works. I don't know. I mean, like, seems to work okay. I don't know. Yeah. All right. So let's put that in. The only thing is that I'm not sure where to actually store it. Like say we do get a PES packet. Where do we store it? Do we put it into the packet here? Probably could. We've got the adaptation field was in an optional thing. We could have the PES packet there. I don't know. What's this? I hate how it's like PES packet. It should be, you know, like, is that the Kim Possible ringtone? No, that would be really, like, that would be really uncool. Loads of people ask me, like, loads of people have mentioned that. Okay, so it needs to be at least, well, actually it needs to be at least 6 bytes, right? So this can go up here. So maybe we're going to put that, yeah, somewhere like that, and then yeah, it must be at least 6. So that's okay. And then we can check the value of the prefix. So we can actually move this up. I kind of like, rather do it like that. Do that and then that, because we don't even store it. We only just use it as a check. So let's do that. PES header prefix. And we could just do return false here. It's okay, like it's not really an error per se. It's an error if we pass it into here, but like we can get that. So if not is PES payload of our of. Okay, there. And what I want to do is, if the prefix is the PES header prefix, then return true. Otherwise, all other scenarios return false. That's clearer. I'll then boy YouTube. Kim Possible, yeah. I'm not going to play that because it seemed to be super strict on like if you play, you know, fucking barely any copyrighted material, it gets picked up. Like the other day, I had a jazz radio station playing like in the other room here. So it's like behind a wooden door and like thick brick walls. And like it somehow picked it up on YouTube, and then you had to silence like 20 minutes of the stream, which is like, it's okay. Like I hope that I didn't say anything really amazing or something. Or maybe it's good if I was talking shit. So alrighty, so move that into this thing, and this is from the payload. Yeah, I think that looking better. Okay, now we can go if we detect a PES payload from payload, then try and get a PES packet out of there. And then if we do get it, then we can store it. Something like that. And then I want to call it PES, like, what is it, like the elementary stream packet or something? Oh, fuck, I can't get a good name for that. But for now, let's get transport stream. So that's there. Okay, leave it over there. This one. Yeah, I don't like that, but you know, I might call it PES packet or something, I don't know. Okay. Let's see if the test runs. Fuck me. Okay, well it ran and passed. So that means that like it may have picked up. Oh no, I haven't saved this yet. Okay, so now we do this. PES undefined, PES packet. Okay, now we can see. Header reports 5,720, have 176. Okay, well there we go. All right. Oh, I know what that is. Yeah, so of course 5,720 doesn't fit. Yeah, that's okay. It's fine. All good. So what's happening there is that the transport stream is like the packet is reporting to us, hey, like this, the elementary stream packet size is 5,720 bytes. So that'll be fragmented over like several packets. And then at the other end, the decoder has to reassemble it. So yeah, so that's all good. So we're not actually, it's not really doing like since we're not doing this for playback, we're just doing it for like decoding purposes. We don't, yeah. Short buffer. seeing how to handle this. So if it's greater than 3, then we know we've got to start decoding stuff. So I guess maybe we don't want to do that bounds checking there. Because, I mean, this doesn't, that's not what we want to do. So that's out, first of all. I think this maybe. We could do bounds checking here. So we could say like, yeah, we're going to get out of bounds. Okay, yeah, it's fine. Makes sense. Yeah, okay. Yeah. Yep. I mean, we could do some bounds checking. We could do the length checks here. Okay, so if of buff onwards from 6 not equal, well, yeah, is less than we know we got a freak out. Yeah. But we only have that. Okay, there we go. H length. Length of, oh fuck. Okay, there we go. Okay. Okay, now the error that we're running into is saying that we are, when we re-slice, we're going past the end of it. So our length at the beginning is okay. But then when we're done, where's the 3 coming from there? Maybe that's... No, this is... we've already read the header length. Now, why would that be 5? It's weird because I feel like this should just be 0. We read that many bytes and then we move on to reading the next. Yeah, it's weird. I don't quite get that. So maybe we're throwing some bytes away by accident. We've just read 5 bytes, so we want to throw away those 5 bytes. Hey, broadcast is such a fun domain. Yeah, it seems to be quite good so far, yeah. Like I say, like it sort of feels a bit more like technology and less about like big sort of software. If that makes sense? If you know what I mean, maybe? Yeah, no, just thinking. Visa web apps doing crud for fintech. Yep. Yeah. Look, so I have a bit of a story. The best project I ever worked on was a big, bad insurance company. How could this be, right? Like, I like doing all this sort of thing. Like, I'm pretty, I'm not very... Anyway, it was this big, bad Java application. It was like 500,000 lines of code or something. Of course, it was developed in that kind of like 2000 and originally developed. Originally developed, fucking hell, like it was. Look, I mean, it's not that old. It was probably like 20 plus years old. And, Java. And it had like all different, you could tell by the code base, you'd see all the different versions of Java. And you'd read like through and it would have all the different like, throughout the time, it would have, you'd see different versions of the software throughout. So you'd see like, version 3, which was done in like, 2000 and like, or 99 or something. And then you'd see like version 4 and then the classes were like, this fucking long, right? They were like, this. So eventually, anyway, yeah, so it was like terrible, right? Like the exceptions, it would just throw like a, what's the what is it in? It would just throw a runtime exception. Is that the one in Java? I can't even remember now. Anyway, the point is that like deep down in the code base, there would just be like, yeah, runtime exception. Yeah, it would just like from way deep down, like how many fucking things deep, and it would just be like throw a runtime exception. And then they're always fun. Yeah. And so then at some point, like the web app thing would just catch it, and then it would just display like an unhappy face to the user in this web app. And it was just like, what the hell? This is so... Okay. So that, that was a bit of a pain, right? And yet it was the best project I ever worked on. Web applets. Yeah. Okay. Yeah. But yeah, this, the manager was fantastic. So the manager was like this, they started, doing like printer support back in the 80s or something. And, they just worked their way up the ranks, so to speak. And they moved back to the Netherlands to get like an easier job. They were based in America initially, from the Netherlands originally, but they were in America. Anyway, it was awesome. So it was like a team of 10 people. There was customer support, testing, database admin, like the sysadmins, programmers, manager, customer support, like IT support as well. So like the internal tech, all in one team. It was like 10, 12 people, something like that. It was incredible. So we could just get so much shit done because we were like this self-contained unit, even though the organization around us was like totally fucked. But it didn't matter. It was really cool. It was a great project. Because we would just, like if we felt like writing a bit of tooling or something, we'd just do that. It wasn't such a big deal. The manager sort of was able to work it out, yeah, it was good. It's great, actually, yeah. Best manager I ever had by a long way. Made such a huge difference. I think it's something that by far, I think it's hard to find good managers, so it was amazing when, good management always helps with the best jobs. Yeah. But it's weird because it's not even appreciated. It's funny, like people are like, oh yeah, oh yeah, my manager's so stupid or something, like, oh, like they don't understand the tech, or like they're just whatever, but it's not like it's a super hard job. Like I think that management is really hard. And I honestly, like, I just don't, it's, it's like, it's hard, it's like doing programming stuff can actually be really hard, right? Like software engineering is hard. I don't think, but management and stuff is also super hard. I feel like, anyway, I don't know. I mean, otherwise maybe everybody would be fantastic managers, which it doesn't feel like that. I don't know. But yeah, anyway. That's the story, yeah. Back to slice out of bounds. Not as bad as managers going out of bounds, right? We've got a compiler to check that for us. No, not even actually. No, not in Go. But anyway, yeah, got something checking that we're going out of bounds. But the poor managers don't have that. They need to do all that themselves. I moved from full-time programming to engineering management, completely different kind of skill, and rare to find someone who can do both people ops and the tech side. Not to toot my own horn. Yeah. Yeah, I mean, yeah, even that skill set, right? Yeah, like that's, yeah. I mean, look, I haven't been doing this for so long, so I don't know, like, I don't have that much experience to draw on, but even the ones who don't necessarily have the skills, in the sense like the technical skills, of course that helps. I'm not sure which one's shit. Yeah, same as me. Fuck. Yeah. Yeah. I mean, like I'm out of work. I don't think I'll do management anytime soon. But yeah, yeah, it's hard. I think also like people want to put like not people, but I don't know. Certainly, I think there's pressure on companies to put people into boxes. But the reality is that everybody's got experience from all different kinds of things. And so until you kind of like, I don't know, for me, it feels like unless I just have like a normal conversation, it's so hard to get the point across that, you know, yeah, like software development, okay, sure, yeah. But like I get infrastructure stuff too, you know, it's just to communicate that is like super hard. But I suppose Rebel, yeah, there's I don't know. I'm like is there that sort of dynamic too, or is it a bit like do people appreciate? I don't know. I'm curious actually. Yeah. Another blood. Oh yeah, no, mate. That battle is long lost. Long lost. That's long gone. That's over the hill and far fucking away. I agree, absolutely, but it's just like fuck. Yeah. Like somebody like the first job I ever had, somebody put fucking literally I got business cards with DevOps engineer on it, and I was like, what the hell? Like that was even back in 2015 or something, and I thought, what? Like, and that was relatively early on in the grand scheme of things, and even then it was like became a, you know, oh, it's funny, isn't it? Yeah. Anyway, I've had fucking bitching and rambling and shit. Rebel says, yeah, 2015 I got a DevOps engineer. I was like, the fuck? All right, let's go through this thing. I'm gonna start printing. Let's start print effing. Let me just look back at this. Okay, so here we're in here, and we've read the length. I don't think maybe the length isn't. Yeah. Okay, the flags are all from here down. Those are all the flags. So the length is the 2, 4, 5, 6, 7, 8. So that's 0. 1, 2. Fuck, I'm 1 off. Oh, no, I'm good. No, and then, and 2, yeah. There we go. So then we read the read it, so then everything else is from 3 onwards. Yeah. How are we getting this? So we're going down. A lot of fucking tooting up in this top right corner here. Oops. The length is, okay, so we read the length, no, I don't care about that. We just care about what's in the buffer. And we're checking, we're checking that, right? So we're going, okay, hey, like is, yeah, and we've resliced okay. No worries. Thanks for stopping by. Enjoy your enjoy the spreadsheets. Don't go entrepreneuring, yeah. See ya. Have a good one. I should finish up soon too. So we 6 plus that, yeah? Okay, so we're good there. Why don't we print? Length is 5. Oh, bollocks. I know. This isn't right. There. See? This isn't it. That isn't the right length. Okay, because we need to do... It's... fuck. Okay. Because the length is after the actual length. So we want to read from... Yeah. Okay, so we're going to do this. And this also isn't correct either. Okay, there we go. That's it. So we want to go flags. Oh no, we'll go href. But I think actually I almost want to do it from up here. Oof, yeah, there's too much going on. I think I almost need to split this up or something. Like I need to. The numbers are getting. There's too many little indices everywhere. I'm getting confused. That's really what's happened here. Quite sure how to do it, but maybe here could actually take all of this out, and then yeah, because this is, as somebody said the other day, you know, don't refactor until it hurts, and I think this has just hurt me. Oh, excuse me. Oh, sorry. I'm allergic to shit advice. But no, seriously, it is time to get all this stuff out. It's getting a bit, you know. Let's do this. So, yeah, like fuck. See, whereas it's already, yeah, this is gonna be way better. So the PES header. Okay, yeah, it's gonna be in here. So we need at least 2, 4, 5, 6, 8, 1, 2, 2, 3. Need at least 3. Oh, point on, fuck it, yeah. Okay, now we're good. I think now I can pull all that out, and then yeah, do that like that, and then we're gonna go like that. Okay. So this is from 1. The length of buff from 1 onwards. No, sorry, from the next one onwards. No. Ah. 2, 4. Oh fuck. Yeah, no, sorry, it's 3 actually. Sorry, 2, index 2. So from, and then from 3 onwards is, yeah. There we go, yeah, and then have, that's what we actually have. Then we can dump that. Oh, I mean, oh, well, we could resize. Then we're good. flags is buff1. We don't want to do that. Don't want to do that. There. Okay, so 1 and 2 and that's where we want to check first. Next up, we check the length. And then there, like that. That's better. Okay, so we've got some sanity checks up top, and then there, this reads much better. And we start our header and then start filling it in. Flags. Yeah. And then, yeah, well, that's it, right? So 2, 3, 3 to 5. Read it out of some buffer that I don't know how long. 4 to 6, so we're going to read it from 6 onwards. Yep. Okay. And let's deal with that later. Go. Okay, now that's going to be wrong, but we'll. Oh, okay. Apparently we got it. Got it already just by splitting it out. I mean, we didn't just split it out, right? I mean, we just sort of had it so that we don't have to think about so many indices. I feel like I want to get it out of here. Let's do that. That's better. This is really fields. Okay, so these ones indicate what fields are present. These ones are actually more like flags. So I know these say flags, but really it's like, hey, like what fields are present in the optional fields. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's it. So this is fields. Okay, flags is there, like that. Now that's looking much better. This is making a bit more sense. Let's go here and then let's get the change that to flags. And then here are the fields. Okay. Now, to make sure 0, 1, 2, 3. Okay, then good. And then we can go equals of. I mean, well, actually we seem to be okay there, but I wouldn't mind, again, getting rid of the, like we've read and made sense of everything. So we've kind of stored all that stuff in memory. So let's like, I just want to restart. I just think that's clearer. And then we can just go, see, because then we've got, oh, well, we've read 5 bytes. Okay, well then, just simple as that, right? And the same as here. It's just one thing to keep in your head. That's way better. We've got memory, you know, we've got RAM for this kind of reason. So we don't have to remember. Get the computer to remember those few numbers and then, like, yeah, it's much better. Yeah. Yeah, it's better. All right. Now, apparently we're reading it all okay, just to make sure. So read, call this decode. We are truly decoding it. Decode PES. Okay, yeah, and we are calling it, so that's good. Sweet. Okay, well then, yeah, I think we got it. So what we can do is we can do our little test again so this is our kind of end-to-end test thing where we're going to read in all of the packets from a file that we know is good, Big Buck Bunny, and we're going to decode them, re-encode them to standard output, dump it onto the dump it to disk, and let's see what Wireshark says, or let's see like compare the timestamps that we get in our PES packets, the presentation timestamps, with the ones that we get from FFprobe. Okay, so we're going to go and yeah, let's just do it. So TS pipe is our little command, and then we're going to read from data, and then that thing. Okay. Ooh, very fast. Okay, cool. And okay, let's do ff probe show underscore packets. Okay, so there's one. So we'll call this, could we grep for the PTS time maybe? Or maybe, let's just leave it like that for now. So we'll call this, so BBB, Big Buck Bunny, and then the one that will go here is run it on our re-encoded file. Sweet, okay, and then that's okay. What do we think? Is this actually gonna? So PTS. Oh, fuck, if we've got that right in one go, I couldn't believe it. If we grep for PTS equals. And let's go any line beginning with, anything not, right? So anything not beginning with the PTS equals plus minus, and you just delete it. I think that's right. No. Or we could just send it through grep. Is that gonna work? Yeah, okay, sweet. Okay. Let's save. I don't know. I'm just like I assume that presentation timestamp is the one that we're like. Maybe let me open it up in Wireshark. I mean, no, it couldn't possibly be. Like, something must be fucked up because there's no way that we're getting the. This has got to be fucked up. I'll tell you why. Because we aren't re-encoding the PES packet yet. We're just not doing it. So that there's no way that this is, yeah. So that's fine. Look, that's cool. I'm going to save this. I'm not going to commit it because it's not good enough. But yeah, that's... Yeah, that's it. So So what we've done is we've got the, we've written a bunch of code to decode the PES header, and at least it doesn't return errors. We're not checking the output of it yet, but I'm not like validating. But I have a feeling it might be okay. And we can't encode it yet, but I guess we'll do that tomorrow. Or something, okay? So, let's do that. Are we good? Are we good? Let's... Yeah. 07 asks, what's happening here? Never used Go. Also, I don't know what's happening. Also, what year is that? 1974. It just looks so primitive, where I live under a rock. Oh, sorry. I'm just about to finish, so I can't. But this recording will just be posted. So if you're curious on like what I was banging my head against, then you can see what we were all working on and stuff in the recording. Let's kill that. Hey, Eiffel Sam. Just closing up everything now. So why don't I do this? Yeah. Yeah, sorry, just be going for about 9 hours. 8 hours, 50 something minutes. So yeah. Yeah, it's good. It's good. Yeah, we've been very productive today, I think. Yeah. So first up, let's I'm gonna okay. So move that out the way. Yeah. Open up. Oh no, thanks mate. That's kind. Yeah, will do. Yeah. Thanks for saying that. That's nice. Nice to hear your enthusiastic interest. Remember, I do this as well to try and, inspire other people to do the same, right? So if you've ever, think you got something to share, then maybe try and, I'll try and listen. So I'm just seeing how to end the stream on YouTube. Here we go. Cool. Alrighty. Oh, nice. That's cool. Awesome. Yeah. No, good stuff. Good. Yeah, so just going to put it on this. Nice. Yeah, that's awesome. Well, it's the same for me, right? Like, I learned so much from people doing this kind of, well, actually, I never watched anybody live streaming code before, or any software engineering stuff, but certainly from reading a lot of stuff, open source stuff, and all that, super useful. So I hope that that's also helpful for some other people too. Yeah. Okay. So I will say good night to YouTube, and everyone else, and just thanks again for coming. As always, if you've got any ideas or really anything, mail it to the mailing list. Super easy. You don't need an account or anything. Just send an email. And if you want to see anything next or whatever, I will do a video about the maybe my background in software engineering and the sort of computer space. That might be a few people asked about that. So I can do that. And that's it. So thanks. Yeah. No, it should be good. There's quite a few people here. I'm not used to you know what it's like when you do this computer stuff. Like normally, you're sort of on your own there, just kind of just sticking to it. So it's weird that there's like all these people. Yeah. Sweet. Okay. All right. Good night, good morning, good afternoon, wherever you are in the world. See ya. Is there something you know? Like, yeah. Okay. See ya.